South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
Good morning, learners. Welcome to the Awqaf SA Grade 12 Maths Workshop. We will be focusing on Maths Paper 2. We are coming to you live and in true effect from Spine Road High School. How's a round of applause there? To all the learners that are connecting via YouTube, please let me know and let us know from which province and which school you are connecting to us from. We have a network of schools from across the Western Cape, especially Mitchells Plain today, that's here in person. We are also beaming this to a cohort of learners at Luhlaza High School in Khayelitsha. This intervention is hosted by Awqaf South Africa, jointly with Spine Road High School, the Western Cape Education Department, among other partners. We're now going to be calling on Mr. Kota so he can get going with the session. Mr. Kota, it's over to you.
Morning, good morning, good morning. Good morning, Cape Town. Good morning, Mitchells Plain. Good morning, all the schools and all the learners coming in online from across the country. Okay, welcome, welcome, welcome. We've got a cracker day today. And let's get started. We ended off with the calculus yesterday. Let's get the whiteboard up. Let's get the whiteboard up and let's get started without any further delays. Whiteboard is up and we are rolling. Bismillah. Let's go. Right. Boys and girls, we ended up here. I want to end up before on the... Let's have a look at this type of a question. They tell you the following is given for the function of f before we start with optimization. So we're going to start with optimization. We're going to finish calculus. And then we are going into finance. We'll then take a break. We'll come back. We start with paper 2. I'm going to start with circle analytics and trigs. We'll go for lunch and we'll end up with Euclidean. Right, so boys and girls, today is a big day. Today is a big day. Hopefully by the end of today, you'll be fully prepped, hopefully ready to write your prelim exams. So the following information is given for the function of f. They tell you f of 4 equals 5. Take this down. Take this down. F of 4 equals 5. F dash 4 equals 7. Find the equation of the tangent. Find the equation of the tangent of f at x equals 4 in the form y equals mx plus c. That's your question. That's your question. Connected from Dubai. Nice. We've got learners from Dubai. I know Mohammed Muzammil is also, I think he's in Abu Dhabi. So we've got Abu Dhabi, we got the UAE, we got Australia, we got UK, we got Cape Town.
Portland
The
High
Mother
School,
City.
Grassy Park High, Raymond Brown.
Okay, let's go. Let's go. What does this mean, guys? What does this mean? This means, watch here. Many of you don't even know how to interpret this. Many of you are looking at it and saying like, what? The fricadelle. When they tell you f of 4 equals 5, it means when x equals 4, y equals 5. That's what it means. That's what that means. What does this mean? It means at the point 4, your gradient at that point, it means your gradient derivative, your gradient equals 7. So your m from y equals mx plus c equals 7. And it's as simple as that. Simple as that. Many of you, when you see a question like this in the exam, you go into shell shock. You start panicking. You start panicking. Somebody is listening to it on YouTube here in the session. Kill your phones.
Or you have a twin brother.
Oh, I got a twin brother echoing at the back.
An evil twin.
Mini me. Let's go. So we got a point and we got a gradient. Come on. Y minus y1 equals m into x minus x1. Have you seen that formula before? Y is equal to mx plus c. Y is equal to mx plus c, but when a pair of coordinates is given and the gradient is given, you can use this in analytics as well. Strandfontein High, Caden Isaacs, welcome, welcome, welcome. So let's go, let's substitute. That's all we want. We want the final answer. It's as simple as that. X and y, gradient equals 7. So y minus 5 is equal to 7 into x minus 4. Y minus 5, 7x minus 28. Here's your final answer coming up, guys. Here's your final answer. Y equals 7x minus 28 plus 5 minus 23. And there we go. You'll get yourself 4 marks for that. Now, I know the calculation was easy, but the challenge for you in the exam is how do I interpret the information that's given? Because if you can interpret the information that's given, you'll be able to do the process that follows. As simple as that. Right. One more type of question before we go into optimization online. How are we doing? I think we got our tech in order. Yay, Hasanain. Let's all give Hasanain and team a nice round of applause for today. Samit, welcome. Thank you, guys.
Take a bow, Samit.
Right, let's go, let's go. Alhamdulillah, I wish it started like this yesterday. But you know what? We don't look into the past. We look forward to freedom. Winnie Mandela say, forward. Let's look forward to freedom. We are moving, Baba, we are moving. Check this question. I know many of you seen this question before. Very important question before we go into optimization. Check this one out. I know you've seen it. Check this out. Take it down. Take it down with me. Take it down with me.
Mr. Kota, when we have a chance, we must just go through an overview of what you're going to be going when you do
Yes.
that's paper 2. So just let me know. I've got the screen here if you want to.
I'll let you know just now.
Okay,
I'll
later.
make a note of it, give it to you. You can set it up. Let's say this point is -4. Let's say that point is 2. This is graph f-x. Now, this is in calculus, guys. This is in calculus. They love this question. You'll come across this. That's your y-axis. That's your x-axis. Who knows? What do you think the question is going to say? If you've worked through past papers, many of you have seen this one before. What do you think the question is going to say? Sketched is the derivative. Have you seen this? No? Of f. That means they're not giving you f. They're telling you sketched is the... You know that the derivative of a cube is a parabola. It's always 1 power less. Yes or no? Yes? The derivative of a cube is a parabola. The derivative of a parabola, 1 power less, is what? A straight line. The derivative of a straight line is a constant. The derivative of a constant is 0. That's how you find how you zero a graph. 1 power less. Agreed? Right. So sketched is the derivative of f. The first question. What do you think? If you guys have mastered past papers, we're about 2 weeks away from prelim exams. Come on, you as a learner, you ought to already anticipate what questions they're going to ask. What do you think the first question is going to be? Give the coordinates of the x values of the turning points of f, for which value or values of x is f increasing. Now they want the x value of the point of inflection of f. Screen? Samit? Who's putting it up? You or them? I'm here. Here we go. All right. Give me a second. Samit, can we get picture here? The x value, let me just put the question so long for you while he gets my screen up. The x value of the point of inflection of f, for which value or values of x is the graph concave up and concave down. Find the derivative. Guys, just bear with us. Find the derivative.
So, Amit, we just need some help over here to get Mr. Kota's whiteboard on.
So sketched is the derivative of f. Give the x coordinates of the x values of the turning point, for which value or values of f is the graph increasing. The x value of the point of inflection of f. Concave up. You can take this question down. Where is it concave up and concave down? And find the derivative. Let's see if we can share it again, yeah? Okay, let's go again. Window. Let's open the whiteboard. Let's go there. Let's go there. Let's go there. You will see this appear in many papers. Right. Now watch. Let's do this together. Let's just see. Show of hands. How many of you sitting here are confident you'll get full 11 marks in the exam here? Be honest. One. Oh my word. Oh my word. 1, 2. Out of 700 on site, 3. Okay. And I promise you, after I explain it to you, you're going to get full marks for this in the exam. Amen. Right, watch. The x values of the turning point of f. Now, what you need to do, watch here. You know what's nice to do for a question like this? Just draw a rough sketch of graph f on the side. That's f. So that you are able to differentiate between f and f dash. F dash is your parabola, your derivative. F is your cubic graph. Okay. Now these two x-intercepts of your derivative are the two x values of your turning point of your original. So -4 and 2. Right, the x values of your turning point, x equal -4, x equal 2. These two x-intercepts, let's write it, maybe as a rule for you to remember. Your x-intercepts on derivative graph is your x values of turning point of f, the original graph. Make a note of that. Remember that. You know why? Come on, think about it. It makes absolute sense. When you found the derivative of f, it became a parabola equation. Then you solve for x. Those two x values were the x values of your turning point. Remember, when you're sketching a graph, isn't you find the derivative, you get a parabola, right? Then you say let y equal to 0 and you solve for x. What does those two x values represent? The turning points of f. So that means these two x values of the on your derivative graph, your two x-intercepts on your derivative are the two x values of your turning point or stationary point of f. Don't forget this. Don't forget this. So you've taken this down. It was just a rule I put down there. Easy for you to remember. Shh, quiet. Now you know what you do. After you do this in the exam, what did I always say? Draw your tangents. Draw a tangent there, draw a tangent there, draw a tangent there. Why? That's going to tell us where the graph is increasing, increasing, decreasing. Isn't it? Always good to have a picture next to you. In your exam, draw a rough sketch. Now here comes the next question. How's our onliners doing there, guys? Here goes my mic. These mics are not built for me. My ears are too big. For which values of x is f increasing? Where is it increasing? From negative infinity up to -4, and from 2 to positive infinity. Or, if you want to put it, somebody asked yesterday, can we put it in inequality form? Yes. You can say x less than -4 or x greater than 2. Are we good, guys? Can you see how you can score full marks in this? Not bad at all. Okay. Shh. Now listen, pay attention to the next one. The x value of the point of inflection, your second derivative. So what does it mean? It's your turning point of your turning point. First derivative is turning point. Second derivative is turning point of your turning point. So here's your turning point graph. This parabola is your turning point because it's derivative. Now I want the turning point of my turning point. My turning point of my turning point graph. This is my TP graph, SP graph, turning point, stationary point graph. The turning point of it, the turning point of your turning point graph is your point of inflection. So this is your POI. So what's your x value here? Come on. Between 4 and 2 is how many units? It's the midway. Remember, that piece is equal to that piece. So 4 plus 2 is how much? 6. 6 divided by 2 is how much? So that means 3 units this way or 3 units that way. So 2 minus 3 or -4 plus 3, what will you get? -1. So the x value of your turning point, x equal -1. Or you can write it -1 and y. The midpoint of your parabola, because it's your axis of symmetry. Hey, I love it. I lip read, you know. You said it. Nice.
Question.
Nice. Yes.
While you're just going there, just clarify, we will be doing maths paper 2. We're just covering
We're
one or two
finishing up
sections.
yesterday. We're finishing up yesterday's session. We're going to go into optimization after this. Then we're going into math paper 2.
So just to clear up the confusion there, we will be doing maths paper 2, but we're just
We're
completing.
finishing up. In fact, we're finishing the calculus now. We're going to do finance and then paper 2. Right. For which values of x is the graph concave up? Right. Now look here. X equal -1. So let's say -1 is somewhere here. Let's say -1 is somewhere there. So concave up is from -1, right? From -1 to positive infinity. In fact, this is supposed to be, hey, you know what? Guys, nobody picked this up. It's a negative parabola. So shouldn't it have been a negative original graph? Think about it. Think about it. Don't you think, listen to me, don't you think that if it's a look, if it was a positive parabola, you would have had a positive original. So you've got a negative parabola. What do you think? That means everything now.
Question,
It's fine.
question, Mr.
Yeah.
Kouta, sorry for stopping
hearing.
your flow. The learners, there's a small protest out there. They're saying the graph, there is something questionable about the graph.
Yeah, I know. We just fixed it now.
Okay, no problem. They're going for my head here.
They're going for your head. They're going
And they know
for
my
your
name.
head. They're going for your head.
And they know my name.
Well, we all human, guys. We all human. And it's good to pick up your error as you're going along. Because I'm looking here, find the derivative, and the derivative is going to give me a negative parabola. That means my original must be a negative. Ooh, astaghfirullah. Astaghs. It's good. I'm glad that we made that error. These are good learning curves. Let's start it again. But it's quick now. The x values of the turning point, that will still stay. X is equal to -4 or x is equal to 2. For which values is it increasing? Let's go here. Let's go there. Let's go there. The original is a negative graph. That's negative, that's positive, that's positive. It's increasing. It's increasing from negative infinity up to -4, or it's increasing from 2 to positive infinity. Right? That's where it's increasing. Where's it decreasing? If they had to ask you decreasing, I'm just writing it here. Where is it decreasing, guys? Between -4 and 2. That's where the graph is decreasing. The x value of the point of inflection, that's correct. X equal -1. Let's say -1 is there. It's concave down from here's it. Watch here, watch. Here's it. You can look at your original, concave down, or you can look at the turning point graph, concave down. So it's concave. So they want to know concave up. Concave up would be from -4. No. For all your x values less than -1. So let's go. So we say for concave up, let's just write for concave up here, for all your x values less than -1. For concave down, for all your x values greater than -1. So here we go, greater than -1, that's down. Up to -1, that's up. On this side here, on this graph, that's up, concave up. And this is concave down. Beautiful. I'm glad we made that mistake. Hopefully you don't make that mistake in the exam. It's a negative parabola. That means my original must have been a negative f, not a positive f. Like I said, I'm not working through a memo here. I'm taking a question from a paper as if we are all doing it here together.
Question.
If you need to make corrective measures along the way, Make your corrections.
Jade
Yes.
saying, for the love of all things good and sacred, that you might be going a little bit off track with that graph. Are we
Why?
Are we
No,
correct?
we're right. We're right. We're
is-
right. We're right. We're right. We're
Are we
right.
right?
We are perfect.
Okay.
We've done corrective measures.
Left to right, not right to left. Are we correct there?
It's correct.
Okay,
It's
there we
correct.
go.
It's correct. We've done the alternate measure because of the slight
The variation.
the variation between YouTube and live.
Okay.
That's why we're picking up. But corrective measures have been done in the 15 seconds.
I think there's a thing called cognitive dissonance.
Cognitive dissonance. Find the derivative. Find the derivative. Onliners, you guys are getting picture and sound about 7 to 15 seconds later. On-siters, you getting it live. So hang in there. Hang in there. Now let's find the derivative. The last question. Find the derivative. So f dash x is equal to minus into x minus x1 into x minus x2. Yes or no? Do you remember this from finding the equation of a parabola from functions? It's a negative parabola. That's why we put a negative in the front. We're at the end of this and then we're going into optimization. And like I promised you yesterday, I'm going to give you one formula to use for all your standard shapes for total surface area. Right, so let's go. F dash x is equal to minus into x, your two intercepts, minus 4 plus 4 into x minus 2. F dash x is equal to minus into x squared plus 4 minus 2 plus 2x minus 8. F dash x, here's your derivative coming up. The equation of this graph, minus x squared minus 2x plus 8. Yes or no? Now, just before we go on to optimization, I just want to show you something. Something nice, something to open up your mind. So when we say we're finding the derivative, it means we are finding the turning point. Yes or no? How's our onliners doing with our slide? Am I redeemed?
I think you're in quarantine.
Am I redeemed from my onliners? Yes, you are. Have I redeemed myself? I was sent to the slaughterhouse for that one. Imagine.
Yeah. Tahir says he's learning a lot, sir.
Please learn this. Okay, now watch this. Watch here. Just to show you something. Just something under functions. If you are given f of x is equal to, let's say they told you x squared minus 2x minus 8 under functions. And you needed to sketch that graph, or you need to give the range of the graph. Right? You can use derivative to find the turning point. Instead of using minus b over 2a, which you know for finding the turning point, how do you normally do your turning point? You say x equal minus b over 2a, am I right? So you don't need to do that. You can just go f dash x, the derivative, because derivative means turning point. So you can say 2x minus 2, power rule, equal to 0. 2x equal to, x equal 2 over 2 is 1. That's your x value of your turning point. And you just take the 1, put it back into the original, and you'll get minus 9. And there we go. You can do it like this. You can even find the turning point of your parabola using your derivative. Because the word derivative means turning point, minimum or maximum. So what would the range of your graph be? Because it's a positive graph, it's got a minimum y value, and the range would be y greater than or equal to minus 9. There we go. It's just something for you to know, just to open up your mind. Okay, and that brings us to the normal end of calculus. Let's go on to optimization. How's our onliners doing? Are you guys ready for optimization? Right. Got it? Give me the screen, give me the whiteboard. There we go. Right. Optimization is very easy. Here's the process. Come on, I promise you, if you follow this process, you'll get all optimization correct. The process is substitute into formula, your x values, substitute into formula. Step number 1. Step number 2, derivative and solve for x. Derivative for minimum or maximum, derivative equals 0 and solve for x. It's like finding your turning point and then sub x into original. To get final answer. That's it. That's the process, guys. 3 steps. Use the formula, substitute x into the formula, like you're finding your turning point for minimum or maximum. Now plug back into the original to get the y value, to get the function value. Now we know there are 3 types of optimization questions. You'll get 1 out of the 3. You'll get that or this or that. What's the first type? You're going to get volume, area, total surface area. Or you'll get a graph. Right? You'll get a graph that looks like that. You'll get a graph that looks like that. They'll say find the maximum distance between these 2 points. I'm just giving an example of what it would look like. And then you've got speed, velocity, acceleration. Right. So I'm going to give you, now, before we do this, let me give you the 1 total surface area. You know your volume formulas for standard shapes. You got to know them. You don't. Ah, come on. A prism, length times breadth times height. A cylinder, pi r squared times height. A triangular prism. Hey, brah, you better go. That's bookwork. You better learn that. Right. You all got this down? You've all taken this down? Let's start with the total surface area. Please don't forget the process. Here is the process. Guys, you follow this process religiously. Step 1, step 2, step 3. Sometimes it's broken up for you into these 3 parts for 9 marks. Then 3 marks, 3 marks, 3 marks. Sometimes it's not broken up like this. They just throw you in the deep end and give you 1 question for 9 marks. You still follow and break it up like this. So if you can follow this, you'll always get it right. Always. I'll show you now. We're going to do application and you're going to love it. Hopefully this is a topic. After doing this, you have to work through at least 6 to 8 past papers. Master them. In fact, from about 2019 or 2020 up to 2025, till your June exam this year, as many papers nationally as you can. Work through KZN papers, Western Cape papers, Gauteng papers. 6 of each. Paper 1, paper 2. You're looking at maybe a batch of about 36 papers that you need to master. Then you know you're confident to walk into your exam. Give me the whiteboard. Can I have the whiteboard? Can I have the whiteboard? Before my head explodes here. Can I get it large? Thank you. Large and in charge. Right, let's go. Let's go. Right, now watch here. Total surface area. Take this down. TSA, total surface area, is 2 for a closed top and bottom. Closed top and bottom of a shape. Let's take this can, for example. It's closed on top, it's closed at the bottom. So the total outside area is, because we have two bases, 2 times area of base, 2 times area of base. Whatever your base is. So if your base is a circle, pi r squared. If your base is a triangle, half base times perpendicular height. If your base is a square, length times breadth. You'll adapt this formula for all shapes. So this is one formula that you adapt, one formula that you tweak for all your standard shapes. Agreed? 2 times area of base plus perimeter of base, whatever your base is. And your perimeter of your base is multiplied by your height. Not everything. So to simplify this for you so that you never forget it, total surface area for closed top and bottom is 2AB, 2 times area of base, plus perimeter of base times your height. Boom. There we go. So whenever the question talks about total surface area, all you're going to think in your mind is 2AB plus PBH. What are you going to be thinking? 2AB. Come grade ones, let's all say it together. 2AB plus PBH. I can't hear. Let's say it again. One more time. What if the bottom is closed? What if that's a drinking glass? What if that's a drinking glass? And what if the bottom is closed? Now what will total surface area? How many bases do I have? So what do you think? How are we going to, will it be 2AB or 1AB? 1AB plus PBH. So you don't need to learn this. I'm just showing you how it can be adapted. And what if it's like a toilet roll holder? What if it's like a toilet roll holder? What if, and it's open on the top and open at the bottom also. So total surface area. Are there any bases here? So can I say 2AB or 1AB? What do you think it's only going to be? PBH. Very good. You're just adapting that formula. So this is open both sides. And this is one side closed. So all we're learning is this formula. 2AB plus PBH. For all your standard shapes. So it could be a cube. It could be a prism. It could be a cylinder. Or it could be a triangular prism. Like what? Give me an example of a triangular prism, like a Toblerone chocolate box. You know, Toblerone chocolate? That box is a triangular prism. we use the same. So triangular prism, cube, a normal prism, like a brick or box, and a cylinder. Don't stress about your unusual shapes, like a cone, a dome, a sphere. They will generally give you the formula for that. In your exam, they'll put a little box, they'll say hint. They'll generally give you the formula for that. But also good to know them if you want to learn them. Right, so let's start with some examples, guys. We're going to finish optimization. We're going to love it. Then we're going to choose the one from a prelim paper 2024. We're going to get it right. We're going to be confident about this. We're going to go for break, for breakfast. We're going to come back and we're cracking paper 2. Or you want to start finance first? Go straight into paper 2.
Mr. Kota, we still need to go through the time for our comfort breaks, eh?
All right, so let's just have a look here
screen?
quickly where we at. Where we at? Let's look at our timing here, guys. It's 20 past 9. I think 10:30. Let's go 10:30 for our comfort break. 10:30 to 11 o'clock. We come back. We got lots of work to cover. Yeah. Okay, it's on your screen now. Obviously, we had to change that entire program because of yesterday's technical issues. So we'll push until 10:30, guys. 10:30 for your comfort break till 11 o'clock. We'll come back and we'll continue with the program. Okay, so let's finish this up.
Thank you, Mr. Kota.
Jazakallah. Here we go. Here we go. Here we go. Onliners, are you all right? So watch here. Let's take a cylinder, for example. Let's take a cylinder. Let's take a cylinder. Right. It's closed on the top and closed at the bottom. That's X. This is 300 minus X. Right. Question number 1. Take this down, guys. Show that the volume of this is given by 942x squared minus 3,14x cubed. Number 2, find x giving maximum volume. Find the maximum volume.
Mr.
So here,
Kota,
this question has been broken up for you into 3 parts. 3, 6, 9 marks. Take this down. It's closed on the top and closed at the bottom. Yebo, yes, Hassanain.
shout out to Logan Stout. He just gave us a super chat on our YouTube. A round of
He's here.
applause.
Let's give him a nice
Yeah! So on our YouTube, if you feel the match session, you can give us a super chat on YouTube. Some of that money will pay for Mr. Kota's contraband.
No,
that
it's
he's
not
consuming.
for me. I'm not taking anything from it. It will help us to go to more places in the country and to help more learners get their distinctions in math. I wish.
7 Rand is the baseline. You can go up to whatever amount, whatever pocket.
Guys,
whatever cash that
remember,
you
while you're taking this one down, just to tell you that this program is brought together by Awqaf. And what is Awqaf? Awqaf is it's an annuity, and people put in money every month in order to support learners across the country. Get me my whiteboard up, please. There we go. So these programs are community-based. The funds are raised by people like you and your parents and the community at large. And it's put into a fund, and that fund is utilized for programs like this, for healthcare, for people who can't afford cataract operations for their eyes, water wells, scholarships, bursaries, and obviously for the community to give back to communities like yourselves and all other communities.
And the point has to be made that Mr. Kota has been part of this program since inception. And next year, we'll be celebrating hosting this intervention across South Africa for 10 years.
this
for 10
year.
years.
This year.
No,
We
it's
started
next year.
2015.
2015. So
We
there
started
we go.
2015. It's
10
2025.
years.
We're celebrating a decade of intervention
Yes,
already.
helping learners.
10 years. Huh? Yeah, I'm a dinosaur, bruh.
Tell them about Rory Sang scored 100%.
Hey, it's my birthday on Wednesday.
Yeah.
I'm turning half a century.
Happy birthday,
Happy
Mr.
early
Kota.
birthday. Right, let's get started, guys. Show that the volume, if given. What the hell is given? Right. What do we know? What did I say? The process. Start with the formula. Volume equals pi r squared times height. Yes or no? Guys, what did I say? What was our process? Start with the formula. Volume equals pi 3,14 because they got a 3,14. They don't have a pi in it. Right. R is your x squared. Your height, 300 minus x. So volume is equal to, remove the brackets and you're definitely getting your answer. So you get 3,14 x squared into 300 minus x. Volume equals, multiply this out, you get 942 x squared minus 3,14 x cubed. Simple, straightforward, plug and play. The next one, find x giving maximum volume. So for minimum or maximum, what must we do? Derivative equal to 0. Excellent. Simple. Right, let's go. Can I erase here? Can we do number 2? Right, we're answering question number 2. So we know volume equals 942 x squared minus 3,14 x cubed. So now, for minimum or maximum, you can write it dv over dx. Derivative, power rule. Power rule. Hassanain. Samit, Hassanain. Just wait. I think let's all start screaming for Hassanain. 1, 2, 3. Hassanain! 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 Let's go! Hassanain! Hassan. Yarra. Just sit here, bruh. Right, let's go. Shh. dV. Now we're finding the derivative power rule. 2 times 942 is 1884x minus 3 times 3 times 3 comma 14 is 9,42x squared equals 0. Power rule. Power rule. Now we solve for x. Now let's check your algebra. You got an x here and you got an x here. Solve for x. Let's take out x. We are left with 1884. I heard the answer from the right-hand side, and that answer is correct. Well done. Minus 9,42x equals 0. So x equals 0, or 1884 minus 9,42x equals 0. What's the name? Okay. You picking it up? Hmm? Yeah. Solve for x there, guys. What answer did you get for x? 200. Excellent. And now do the last one while he's getting us up. Find the maximum volume. Take the 200, put it back into original. Take the two, what do you get? 1,256,000 units cubed. Yes. Give yourselves a nice round of applause. You just worked out optimization. What must I do? Completely? No, I can't do that. All right, let's just don't save. Let's just open up another one here for you. There we go. There we go. Not from my side. Okay, let's go back here. We back there. Let's go share. Am I in?
Mid.
Yeah. Here we go. Shared. So what did we get? We had volume is equal to 942x squared minus 3,14x cubed. So volume was equal to 942 into 200 squared. I know it's not sharing at the moment. It's going to share any second. Are we back? Give me the whiteboard there. If we do this on our calculator, 1,256,000 units cubed. There we go. We found x to be 200. Yes or no? Excellent. And there we go. That's your volume of your shape. Now, let's take the one from the prelim paper. Are you guys ready to go deep sea diving? Swimming with sharks. Right. Take this one down. We're going to do one like this, and then we're going to do one graph. Speed, acceleration. Can I get the whiteboard again? Nope. I'm getting a screen here. There's something. Yes. Yeah. No, but just don't. Yeah, okay. Okay, so there we go. There we go. Right, let's start. Let's take this diagram down here, guys. We're going straight into the one from the prelim exams. Take this one down with me, guys. Take it down with me. Right, let's go. Right, that's C, B, Y, D, X, F, A, E. They tell you that this piece here is equal to that piece there. The diagram below shows the plan for a veranda. The veranda is going to be, so they put a cottage here. That's a cottage, and then this must be the veranda. Right, which is to be built on the corner of a cottage, a railing A, B, C, D, E. A, B, C, D, E is a railing. A, B, C, D, E is a railing around the veranda. A, B equal D, E equal X. A, B equal D, E. A, B equal D, E equal X. BC equals CD equals Y. The length of the railing must be 30 meters. Right. Calculate the value of X and Y for which the veranda will have a maximum area. Now they threw you into the deep end. One question for 8 marks. Find X and Y for maximum area. 8 marks. 8 marks. A, B. Sorry, guys, just don't put these two as equal. We can't assume because they don't tell us A, F equal. They say A, B equal D, E. So just take this out, take that out, and take that out. Those two lengths are not equal of the cottage. Okay, there we go. Right, go for it. We want everything. Now remember, for maximum area, so we need length times breadth. Area equals length times breadth. So you need the whole length and the whole breadth in terms of X. FE equal. Right, come guys. Take it down, try it on your own. Apply yourself. This is from a prelim paper. Just want to read the question again. The diagram below shows a plan for a veranda which is to be built on the corner of a cottage. The railing is to be constructed around the four edges. AB equals DE equals X. Right, there we go. Okay. So now we need the length and we need the breadth in terms of X. I'm giving you a chance. Take it down, apply your mind, apply your mind, apply your mind. And they tell you AB equals DE. AB equals DE equal X. Right, so that means that piece there, AB equals DE equals X. BC equals CD. BC equals CD. BC equals CD, which is also equal to Y. Let me see. BC equals CD, which is also equal to Y. Right. So please insert your information very carefully. So what would this entire length here be? This entire length would be Y, right? But now remember something, we want this piece here, right? So Y minus X will give me FE. FE is Y minus X, right? So let's go here. The entire side is Y. That small piece is X. That means this remaining piece here, FE, is Y minus X. There we go, Y minus X. Let's look at AF. Let's find AF. This entire side here is Y. That piece there is X. That means AF, that piece there, is also Y minus X. Now we've proven those two pieces to be Y minus X. Right. The perimeter of the railing is 30. Because the length of the railing must be 30. So if perimeter is 30, so perimeter is equal to 2y, 2 of the whole y. So it's AB plus BC plus CD plus DE. So let's work this out. The perimeter, which is 30, the perimeter is going to be AB plus BC plus CD plus DE. The entire thing. So what is AB? What is AB? X. What is BC? Y. plus what's CD? Y. Plus what's DE? X. Now it's around the cottage. So basically, we're only looking at that, and that. You're not looking at this and that. That's the house. It's around. The veranda is around the house. So the railing will go like that. The railing won't go here and there. The railing is around. So perimeter is equal to 2x plus 2y. And we got the perimeter 30 equals 2x plus 2y. Right. Now we know that the area in terms of x, so we know that y. If we want to find out what is y in terms of x, let's do it together. What is y in terms of x? I'm just erasing all this on the side. I'm erasing all this on the side. So from here, I can say 2x plus 2y equals 30. 2y equals 30 minus 2x. Y in terms of x, divide by 2, divide by 2, divide by 2, it's 15 minus x. Yes or no? Right. So that means instead of me putting y, I can say y is 15 minus x. Now, they said for maximum area, find x and y for maximum area. So we know area of the shape is the area of the whole rectangle minus the area of the cottage. So area is equal to length times breadth minus the area of the cottage is also length times breadth. So the area in terms of x is going to be length times breadth. So it's 50. In fact, what we can do, firstly, we can put it in terms of y, right? So we got y times y. If you want to put it in terms of y, you got y squared minus the area of this would be y minus x squared. The area of the whole rectangle, the area of the shape is the area of the rectangle minus the area of the cottage. I'm moving over to the side. Let's remove the brackets. Let's get the area in terms of x. Let me put a line down here. Let's continue on the right. Come, let's remove the brackets here. The area in terms of x is equal to y squared minus, now let's break this up. This would be y squared minus 2xy plus x squared. So area in terms of x is y squared minus y squared plus 2x minus x squared. This is equal to 2xy. Is it? Oh, yes, it's 2xy. Thank you. Minus 2xy. So y squared minus y squared will kick out. We're left with 2xy minus x squared. What is y known as? We can now remove y because we want everything in terms of x. So it's 2x. What is y? 15 minus x squared. Now we're getting everything in terms of x. We've converted y in terms of x. So what would this work out to? If I multiply this out, what would that give me? 30x minus 2x squared minus x squared. This would be 30x minus 3x squared. That's your area in terms of x. But what did they ask you? Find x for maximum area. Why am I changing everything in terms of x? Because the question says, find x for maximum area, x and y. So we first putting everything, we converting all our y's in terms of x. Now, continue from here. Continue. You need to find the derivative for minimum or maximum. I'm just removing the diagram. We don't need the diagram anymore. We don't need the diagram anymore. I'm moving to the side. Area x equal 30x minus 3x squared dAx over dx. Derivative of area over this is 30 minus 3x equals 0. Minus 3x equal minus 30. Divide by minus 3. Divide by minus 3. X is equal to 10 meters. Is it right? Ah, okay. At least you locked in. 2 times 3 is 6. X. You equals 0. Minus 6. Yeah, guys are sharp. They're on fire here, brah. 30 divided by 6 is 5. And what we got? We got y is equal to x minus 5. 15 minus 5. Am I right? What was y? 15 minus x. Am I right? Y was 15 minus x. Remember the length of the side? So let's find y. Y equals 15 minus 5. Y equals 10. There we go. There we go. How's our time? 9:50. We're not bad at all. I'm going to do one more in terms of graphs. I'll give you one more in terms of graphs. Yeah. Yeah. So these are your x for minimum and maximum. This is x and y for minimum because we use derivative. We've solved for x for minimum or maximum. Whether it's minimum or maximum, derivative is equal to 0. You don't need to do two separate problems. Minimum or maximum, derivative equals 0. Now the next one's a very popular one, and there's a reason why I'm choosing the next one. So that you understand what to do when you see a graph. You're going to love the next one. You are actually going to love the next one.
Mr. Kouter, do me a favor. Give a shout out to the learners at Luslaza High School. We are beaming the session for the first time to the school in Khayelitsha, Luslaza High School.
Lovely. Luslaza was here yesterday. Big shout out. Guys, let's give a nice shout out to Luslaza High School in Khayelitsha.
Yeah.
All the learners are at their school. They were here yesterday. They were here yesterday live. Today they've all gathered at their school and we're beaming directly to the school. Yeah, we've set up the whole infrastructure for internet. Amazing, amazing.
So the same
and it's going so well.
At Spine Road as well.
And at Spine Road. Welcome. Well done, well done. Well done, guys. Well done. This is how, hopefully, our mission for next year, hopefully, say inshallah, Ameen, we hit the ICC. Cape ICC, what 5,000, 10,000 online live learners. Are you guys going to join us there? Yeah, even if you pass, at least come say hello. Oh, I don't want to read the comments. What they say? How's our bras on site, online? So that's the scene at Luslaza. Oh, wow. Wow, beautiful. Beautiful. Okay, let's do this. Take it down here. Take this diagram down. Take this diagram down. Now they give you a parabola. This is calculus application now. And they give you a rectangle. Let me just draw this quite. There we go. Take this one down, guys. They give you a rectangle in here. Right. They tell you that is 0. They tell you that piece is equal to this piece. This is P, Q, R, S. They shade that part in graph F. F of x is equal to minus 3x squared plus 18. They tell you that is x. Right. Here we go, guys. Here we go. So OQ equals OR equals X. That's all they give you. PQRS is a rectangular piece of land within a river that's shaped like a parabola. Find the maximum area of PQRS. Find, one question, 8 marks. Find the maximum area of PQRS for 8 marks. 6 to 8 marks. So basically, we know what we need to do. We need to find the area in terms of x. We need to find x giving maximum area, and we need to find the maximum area. So we need to do it in 3 parts to get our 8 marks. This is the last one we're doing in optimization. Last one we're doing in optimization. Then what you say? You want to give them a break? Break after this or 10:30 break? 10:30. Okay, excellent. Okay. I'll give you guys 5 minutes to figure this one out. 5 minutes. All of you, online and on-site, you got 5 minutes to work this one out. I'll go for a short oxygen break. Hasanin can take over.
Okay, so while Mr. Kota oxygenates himself, just give him a chance to stretch his legs. We will be resuming shortly with maths paper 2. Thank you for your...
5 minutes, guys.
No, 2.5 minutes. So we will be resuming shortly. Mr. Kota will be resuming in the next 5 minutes. In the meantime, we do have a cohort of learners at Lushlaza High School in Khayelitsha. Shout out to you. Thank you for attending. This is the first of these broadcast sessions that we are hosting at schools. We are aware also that the session has been beamed to a cohort of learners in Soshanguve, in KwaZulu-Natal, Plumstead High School. So we're very appreciative for your attendance at Lushlaza. So Khalid Romano from Awqaf South Africa, he is in attendance with a cohort of learners. We're just taking a brief break, and in the next 2 or 3 minutes, we will be resuming. Mr. Kota has been going through a few questions from Maths Paper 1 that was not dealt with during the session on Saturday, yesterday, and we will be resuming shortly with the Maths Paper 2. We will be taking a break at 10:30 until 11, and then we'll go all the way through session 2 from 11 o'clock until 12:30, and then at 12 until 1:15, that's when we take our lunch break, where you get a chance to get some fresh air, stretch your limbs, and then we'll go all the way from 1:15 all the way to 3 o'clock. These sessions are hosted via Awqaf's YouTube platform, so you can refer back to these sessions. Hashtag Awqaf South Africa, Awqaf SA Maths for your TikTok Reels and your social media update. Hashtag Awqaf SA, awqafsa.org.za. And these sessions, you can refer back to it. It is being hosted via Awqaf's Facebook as well as YouTube platform. We will be resuming shortly. Thank you so much.
You are suffering. Give me screen. Give me screen. We're back, we're back, we're back. Now, so here's the trick of this. If that is x, then that is x, then that whole side is 2x. Right, now pay attention. Now you people having difficulty finding the side in terms of x. So come on. If this is x, that means r's x coordinates is x. Now, in my mind, I was thinking if it was 4, then we make it 4. But okay, it's x and 0. And s, the point on the graph, is also x. And its y value is f of x. The y value is the equation of the graph. Minus 3x squared plus 18. So that value is minus 3x squared plus 18. The y value is the function value. If this is x, no matter what it is, we have to plug it into here to get the y. So that's your y value. So area, length times breadth. Your length is 2x. Your breadth is your function value, is your y value. And your y value is given by that. Minus 3x squared plus 18. Now, minus 6x cubed plus 18 times 2 is 36x. That's your area in terms of x. Length times breadth. 2x times minus 3x squared plus. So anytime, and this is going to happen many times. There's a reason I showed you this question. Anytime you don't have an x value on a graph, call it x, and whatever equation they give you of the graph, that's your coordinate, x and f of x and y. And that will help you. In fact, if you want to, I'll do one more like this, right? to put it into the picture for you. And I'll even take out one from a past paper. Right. So now dA over dx, we want the maximum area, minus 18x squared plus 36 equals 0. Divide by minus 18, you're going to have x squared minus 36 divided by 18 is 2, is equal to 0. X squared is equal to 2. X is equal to the square root of 2. Plus or minus, but we always use plus. Distance is always positive. So x is equal to whatever x is. What is square root of 2? 1, just work it out. 1,14, I think, or 1,41. So x is 1,41. That's x for maximum area. They say find the maximum area. So now area is equal to, there we go. There we go. Here's our final answer coming up. Minus 6 into root 2 cubed plus 36 into root 2. What's your final answer? 33,91. I don't know. $33,94. 33,94. Nah? Work it out. Give me a correct answer there. It's right. 33, okay. Don't crucify me here, brah. How's it to Rene?
These learners are sharp, Mr. Kota.
There we go. That's your final answer, 33,94 units squared. We found the area in terms of x. We did the derivative and found x. And there we go. Step 1, step 2, step 3. Done. Let's do the last one. Let's do the last one in terms of now use the same concept. Where if I don't give you x, you call the point x and you call the y f of x. Onliners, are we alive? Are we alive and kicking? Check the next one out, and I know you've seen it before. Right, so they give you something. This is still under optimization. They give you a graph going like that. That's graph F. They call this point A. They call that point P. They call that point B. And they give you a distance here. They also then tell you that f of x, they tell you that f of x, the function value here, the function's equation, that's a parabola, is, let's say, 3x squared plus 8. The coordinates of P is 0 and 12. Right. Find the maximum length of PB for 8 marks. So basically they tell you this could be a cliff, this could be a river, there could be a hippo in the river, and there's a shooter on the cliff, and the shooter wants to shoot the hippo in the river. So the river's equation is given by 3x squared plus. So this is the river. That's the shooter. And let's say that's a buffalo. So the shooter wants to shoot the buffalo. We want the maximum distance between the shooter and the buffalo. Find the maximum length or distance of PB. That point is B. For 8 marks. Again, the same thing. Find the length in terms of x. Find x giving maximum length. Find the maximum length. Same thing, same concept. Come onliners. Dala this.
Mr. Kota, a shout out to Usuzazo and Lushlaza in the house, Khayelitsha. Give a shout out.
Wow, wow, wow. Thank you guys for all tuning in from all the different schools across the country. Hit us up from the area that you are tuning in from.
Our man Khalid,
Khalid is there at
representing Khayelitsha for us today.
Making magic happen from that side. Massive coordination here. Teamwork makes the dream work.
Keeping the whiteboard up.
Keeping our whiteboards up.
Raid says, Mr. Kota is the GOAT. Love from Darul Naim.
Nice. Well done, well done, well done.
Representing.
Hey, who watched Khamzat this morning? Hey, go Khamzat. Who are you guys supporting? Drikas or Khamzat? Drikas! He got whooped this morning. Anyway, Khamzat. Gonna smash your boy. He got smashed. Drikas got smashed. Right, what is B's coordinates? The reason why I gave you this because you need B's coordinates. We don't have it, we call it X. Its Y value is 3x squared plus 8. Did you do that? At least. Thank God. That's why I showed you, if you don't have a point, call it X, and the Y value is the equation of the graph, the function of X. Now, length, distance. Let's go. We're going to do this one and then we're going for break. We're going for breakfast. Right, watch. Let's all do it together. Now, from analytics, the length of a line, PB squared. Don't use PB equals the square root. Use PB squared. Learn this. I've seen this in many past papers. So PB squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. So PB squared is equal to, let's call this x2, y2. So x2 minus x1 all squared plus y2 minus y1 all squared. So PB squared is equal to x squared plus 3x squared plus 18 minus 12 is 6 squared. So PB squared is equal to x squared. I'm just removing the brackets now. Algebra. We're squaring a binomial. Oh, it's 8. My word. What's wrong with me today? What the hell? 3x squared plus 8 minus 12. 8 minus 12 is minus 4. Let me just double check. X squared plus 3x squared plus 8. There we go. Minus 12. In fact, yeah, it's right. 3x squared plus 8. Yeah, that has to be 8 because that's your lower value. A's value would be 0 and 8. So that's correct. I'm just double checking everything is all correct. If that's 8, that has to be 12. It has to be higher than that. That's correct. So 3x squared plus 8 minus 12. 8 minus 12 minus 4 squared plus. Right, let's go. This will give me 9x to the power 4. Square the first term. Multiply the 2 inside the brackets and times it by 2. Minus 12 times 2 is minus 24x squared plus 16. So PB squared is equal to minus 24 plus 1 is minus 23x squared plus 9x4. So let's do it in order. Let's say 9x4, 9x4 minus 23x squared. 1x squared minus 24 is minus 23 plus 16. Right, so that's PB squared. Now we want to find x. So dPB squared over dx is 36x cubed minus 9 times 4 is 36. 2 times 23 is 46x. This will fall away. Is equal to 0. Let's take out x. We're left with 36x squared minus 46 equals 0. So x equals 0 or 36x squared minus is equal to 46. X squared is equal to 46 divided by 36. Work it out. 46 divided by 36. Let me take out my calculator here as well. FX 991. There we go. Boom. There we go. So let's go. 46 divided by 36. 46 divided by 36. 1,28. 46 divided by 36 is 1,28. X is equal to the square root of 1,28. I get 1,13. Right. X is 1,13 for maximum length. Now I want the maximum length. Therefore, the maximum length is now going to be, so take this one, so PB squared. PB squared is equal to 9 into 1,13 to the power 4 minus 23 into 1,13 squared plus 16. I'm going to move over to the side here for space. Let's do the answer here on the top. Let's draw a nice box here on the top. We'll do it here on the top. Here's the answer coming up on the top. So PB squared is equal to, let's go, 9 into 1,13 to the power 4 minus 23 into 1,13 squared plus 16. 1,3. 1,305, blah, 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 blah. Yeah, 1,31. So PB squared is equal to 1,31. We want PB on its own. Here's your final answer coming up. Therefore, PB is equal to the square root of 1,31. 1,14. And if it was in kilometers, then that would it be, or 1,14 units or 1,14 kilometers. The distance between the shooter and the buffalo. And that's how you're going to get 8 marks for that in your exam. Boys and girls, this has brought us now to the end of optimization. It's brought us now to the end of calculus. Guys, what we can do, let's go for break. Let's come back at 11 o'clock. Do you guys want to do, then you guys want to go straight into paper 2? Let's go into paper 2, or you guys want to do finance after break? All right, so let's go straight into double and compound angles after break. Okay, guys, enjoy your break. We're going for break now. It's 20 past 10. I'll see you back in here on the dot 11 o'clock. Break till 11 a.m. Okay. Welcome back. Hope you guys enjoyed your break. Onliners, how are we doing? Are we winning? Let's go. Right, before we entering paper 2 now. We are entering paper 2. Okay. I want to start off with one component on circle analytics. And then we will enter trigs. So let's start off with the circle analytics component, guys. Okay. So we've got a circle here. I'm choosing from a past paper. Guys, at this point in time, it's not necessary or it's not important which past paper I use because it's just a model of explanation. Once you understand that model, you can apply the concepts to any past paper. Okay, so let's start here, guys. Take this diagram down with me. So, in fact, let's go here. Let's do that. Right. Let's take this down. Take it down with me, guys. Take it down with me. In fact, that touches that point there on the circle. Samit. Here we go. That's T. That's 0. That's S. This angle here is angle theta. That's R. That's the center P. Here we go, guys. Here we go. I'm doing one component, guys. One component as a practice. Okay. The diagram below shows circle with center P and the equation x squared plus y squared minus 6x minus 4y equal 12. The circle cuts the y-axis at point R and S. RT is a tangent. RT is a tangent to the circle. Angle alpha is indicated. The first question, find the coordinates of P and the radius. Question number 1, find the coordinates of P and the radius. For 4 marks. Now, I'm not going to give you all the questions. Let's do it question for question. Okay. Take this down. Guys, I'm going to show you another, it's shortcut time. What is it? Shortcut time. So I'm going to show you a shortcut of completing the square. You can get your answer in one line. You're going to love the shortcut. You're going to love the shortcut, so you don't have to complete the whole thing, complete the square on the left, complete the square on the right, expand it, and then bring it. No. That normally takes 5 lines. We're going to get the answer now in one line. In fact, if you're really good by looking at it like how we did yesterday, you can get the answer. I can already look at it now, just to show you, but I'm going to show you how it's done. I can already look at it and tell you what's the coordinates and the radius. Excellent. So you got minus 3, minus 2. 3 and 2. 3 and 2 is the center of the circle. 25 is the 25 is r squared. R is 5. How did I do it? Now I'm going to show you how I did it. Right. So pay attention, guys. This is a very valuable tool. Shortcut. Shortcut. Right, let's put it into proper form. X squared minus 6x plus y squared minus 4y equals 12. There we go, standard form. X squared x, y squared y equals a constant. X squared, next to x squared, you must put x. Right, now here's the shortcut. Right, put your pens down, otherwise you're not going to understand it. Right, so we want the answer in one step. So watch here. X squared, x, y squared, y. There's a minus there, I put a minus. If there was a plus, I'd put a plus. Minus there, I put minus. Okay. So like I said, the shortcut, we need to complete it in one step. So this is how we do it. To get that value and to get this value. Watch here. So all we do here, the coefficient of x, divide by 2, right? Watch here. Divide by 2. So 6 divided by 2 is how much? 3. Plus this x value that you divided by 2, square it. So that would be how much? 3 squared is how much? So you divide by 2 plus x squared, coefficient of x squared. So 6 divided by 2 is 3. On this side, 3 squared is how much? 9. And what you do to x, you do to? So divide by 2 plus x squared, divide by 2, 4 divided by 2 is 2, plus y squared, 2 squared is 4. So 12 plus 9 is 21. 21 plus 24 plus 4 is 25. There we go. You got your answer in one step. The center of your circle is 3 and 2. R squared is equal to 25. So R is equal to 5. Done in one line. Divide by 2 plus x squared. Divide by 2 plus y squared. Let's all say it together. Divide by 2 plus x squared. Divide by 2 plus y squared. Let me hear you guys say it. Last time? Nice. 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 So there's it, done. The center of your circle is at 3 and 2. The center of your circle is at 3 and 2. And because this is a tangent, my radius is 5. Yes or no, guys? Do you want to try one quick one to try on your own to find the coordinates of the center of the circle and the radius using the shortcut? Okay, so try the next one quickly. X squared plus 10x plus y squared minus 2y is equal to 2. Right, quickly. This is a different problem altogether. It's a different example. It's got nothing to do with the previous one. I just want to test whether you know the shortcut. Try it. Get me the center of the circle and the radius. Whoever is smart, you'll be able to do it just by looking at it. Won't it be x plus 5 all squared plus y minus 1 all squared is equal to 2 plus 25 plus 1, 28. That means your center of your circle is going to be minus 5 and plus 1, and your radius is going to be the square root of 28. Let's see if you get that. Divide by 2 plus x squared, divide by 2 plus y squared. Onliners, I hope you're getting it right.
Request, a sincere request from Raymond here. He wants you to repeat that mantra you were repeating with the rest of the cohort.
Divide by 2 plus x squared, divide the coefficient of y by 2 plus y squared.
There we go, Raymond.
That's what we were saying. 6 divided by 2 was 3, and you square it on the other side to give you 9. 4 over 2 is 2, and you square it on the other side to give you 4. 12 plus 9 plus 4 gives you 25. Divide by 2 plus x squared, divide by 2 plus y squared. Danko. Let's do this. X plus, divide by 2, 5 squared. Let's add, 5 squared is how much? 25. Plus y minus 2 divided by 2 is how much? 1 all squared is equal to, we add on 1. 26 plus 2 is 28. Your center of your circle for this one is minus 5 and 1. R is equal to the square root of 28. How many of you got that one right using the shortcut? Well done. Give yourselves a nice round of applause. Well done. Well done. You've now just used the shortcut to find the coordinates of the center of the circle and the radius. Okay, so now that we got the center, we've answered question number 1. Let's go on to question number 2. Remember, you're getting 2 questions in your paper. 2 analytics questions, 1 grade 11, 1 grade 12. 20 marks, 40 marks, 35 to 40 marks. Analytics, score full marks here. Right, next question. Question number 2. Show that the coordinates of R is 0 and 6. Show that R is 0 and 6. That's R. That's R. Show that the coordinates of R is 0 and 6. Now we got the x value here as 0. We don't have the y value. Are you guys with me? Grade 12s, you following? Right. We got the x value here of R to be 0. We don't have the y value. We got the length of the line 5. And we got another pair of coordinates. So we're going to be using the distance formula. Are you all with me? Right. So PR, in fact, PR is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. That's your distance formula. So PR is 5. That's given to us. PR is 5 is equal to the square root of x2 minus x1 all squared plus y2. In fact, let's do this one. Let's keep y positive. So let's make that 2. So 0 minus 3 all squared plus y minus 2 all squared. So, right? So PR is equal to the square root. In fact, what we can do now, guys, square this side, square that side. Square both sides. So 25 is equal to 0 minus 3 is minus 3 squared, which is 9. Plus, let's remove the brackets. Remember, I squared this side, I squared, so I'm done with the square root. So now I'm left with y squared minus 4y plus 4. Bring the 25 on the other side. Y squared minus 4y plus 4 plus 9 minus 25 is equal to 0. Right? There we go. Y squared minus 4y plus 4 plus 9 minus 25 equals 0. So y squared minus 4y, 13 minus 25 is minus 12, is equal to 0. Let's factorize that equal to 0. Y, 6 and 2 minus plus y equals plus 6 or y equals negative 2. So therefore they say show that the coordinates there. So obviously this is 6, 0 and 6. R's coordinates, therefore R is 0 and 6. That one's out. And there you go, you got your next 3 marks. The first one, where you had to find, where you completed the square, that was 4 marks. So 4 and 3, you got 7 marks already. Find the equation of the tangent RT. So those of you who have taken this one down, you can do the next one. Find the equation of the tangent RT. EQTN equation of tangent RT. Right, let's go for that. Those of you who have taken this one down, you can start with number 3 already. The equation of a tangent is y equals mx plus c. So we got a point 0 and 6. I got a point on the graph. The only thing I'm short of is what? M. I'm short of the gradient. That's all I'm short of. I am short of the gradient. I just want to write this one. What did we have? We said x minus 3 all squared plus y minus 2 all squared was equal to r squared, 25. I just want to keep that at the back of our mind. We want the equation of the tangent. Right. So we got r's coordinates, 0 and 6. We can find the m of your radius, because your radius is 90 degrees to your tangent. M radius, yes? No, OP is not parallel to that. You always have to use the radius and the tangent, because you know radius is 90 degrees to tangent. Right, pay attention. So the m of your radius is y2 minus y1 over x2 minus x1. 6 minus 2 is 4 over minus 3. Therefore, the m of your tangent is equal to 3 over 4. You change the sign and flip the fraction. Why? Because your radius is 90 degrees to your tangent. The m of line 1 multiplied by the m of line 2 is equal to minus 1. So you change the sign and flip the fraction. Therefore, the equation of your tangent is going to be y minus y1 equals m into x minus x1. Now we just substitute. You got the point, you got the gradient. Y minus 6 is equal to 3 over 4 into x minus 0. Y minus 6 is equal to 3 over 4x. Here's your final answer coming up. Y equals 3 over 4x plus 6. And we don't think we write, we know we write, because it cuts here on your y-axis. Y equals 3 over 4x plus 6. Right, guys? The next question, find the size of angle theta. Find the size of angle theta. This was question number 3. We're now on to question, no, that was question number 3. We're on question number 4, find the size of theta. Let's now find the size of theta. For those of you who have done this, now find the size of angle theta. For another 3 marks. Now we know, I'm just checking what we know. That's a 90-degree triangle. That's not going to be hard. To find theta is going to be easy. To find theta is going to be easy. All I'm going to do is going to find this angle here. And I'm going to use, that's a 90-degree triangle. Exterior angle is equal to the sum of the interior opposite angles. That's how I'm going to find it. But firstly, I need to find angle T. Agreed? Are you all with me? You need a strategy in your mind before you even start the problem. So what's your strategy here, guys? Let's find angle T. RTO. RTO. So 10, we're going to use the angle of inclination. So I'm answering question number 4, finding angle theta. Right, so I'm finding this angle here. So tan of angle RTO is equal to the M of line RT. So tan of RTO is equal to, we got the gradient, 3/4. So angle RTO, we're looking for an angle, use the shift key on your calculator. Let's go to our calculator. We go shift tan 3/4, 36,86, 36,9. 86, 87, 36,9, no problem. So this angle here is 36,9. That angle there is 90 degrees. What do you think angle theta is going to be? Exterior angle equal to sum of interior opposite. Theta is equal to 90 plus 36,9. Why? The exterior angle of triangle is equal to the sum of your interior opposite. Boom, here's your final answer coming up. 90 plus 36,9, 126,9. And there we go. Right. A vertical line is drawn as a tangent to circle P. Okay, now watch. Let's do question number 5. That was question number 4. Let's see if you guys, those of you who are still taking this one down, those of you who are done, you can do the next one. A vertical line is drawn at point Q, A, and B as a tangent to the circle, where A is greater than 0, A being your x value. Find the coordinates of Q. And your mark allocation will guide your level of difficulty. It's only 2 marks. A vertical line, let me repeat this for you. A vertical line is drawn at point Q, A, and B as a tangent to the circle where A is greater than 0. Find the coordinates of Q. Oops, sorry, you can't see there in that corner. Eh? Find the coordinates of Q. So we're done with this, done with that. Let's write the question here on the top. Find, with regard to this question here, find the coordinates of Q. And it's only 2 marks. Agreed? So your mark allocation guides your level of difficulty. If it was a 5-mark question, obviously you know, serious calculation. 1 and 2 marks, it means basic stuff. Don't think too deep. So let's draw a vertical line. That's the only thing we can do. A vertical line is drawn where your x value as a tangent to the circle. Where your x value is greater. So that's point Q. A and B. Your y value will be exactly the same. We are just short of the x value. Yes or no? So all we do, watch here. This will be definitely in line with that. So if this value here is 3 and my radius is 5, what will this x value here be? 8. 3 plus 5 gives me 8. So Q's coordinates is 8 and 2. Are you guys following? No rocket science here. No rocket science. Now comes your higher order. You got 2 higher order questions. We're wrapping up. We're wrapping up the circle analytics. And then we're going into trigs. The fun is going to start. For many of you, it's not the fun is going to start. The kak gaan spat. No rakidang. Right, let's look at the next question. Take the next question down. This is question number 6. For which values of k yes will y equals 3 over 4x plus x, plus k be a secant to the circle? What they say? Oh, they don't know how I got 8 and 2. Okay, you guys want me to repeat question online? You guys want? Right, they told you a vertical line is drawn where A is greater than 0. So we drew a tangent here. Let's just draw the tangent. I'm just doing number 5. So we drew a tangent there. Now we know the same y value here because this is now going to be a straight line. So the same y value here is going to be the same y value for Q. So let's erase that. Let's erase that. Let's erase that. Right. So the same y value here is the same y value as P. That would be 90 degrees. So that means that is 2. The x value of P is 3. From there to there is 3. Now from here, from here to there, it's a radius. Your radius was 5, so the radius here is 5. So 3 plus 5 is 8. The x value. 3 units this way to point P. From P to Q is 5. 3 plus 5. 3 plus 5. Right, onliners? Thank you. Okay. Now, for which value or values of K will this be a secant to the circle? What is the meaning of the word? A tangent touches at 1 point. A secant touches at how many points? 2 points. If you got a circle and you got a straight line cutting there, that is called a secant. As long as it's not a diameter, doesn't go through the center. So if you got a straight line that cuts a circle at 2 points, it's called a secant. Right, let's see. How sharp are you guys? Come answer this question. For which value or values of K will 3 over 4x plus K be a secant? That means, watch here. That means this line here, that line there, it's a tangent at the moment, and it's 3 over 4x, 3 over 4x. Now, it touches at 1 point. So we know that it must be less than 6. Because if it's less than 6, it will be like that, 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 like that. And it's got to be greater than the other point of contact. Right. So we know, number 1, we know that K must be less than 6. Now, it needs to be greater than the other point of contact. So it's between the two. Remember, this is a parallel line. This line is going to come down all the way here, right until this point here. Let's draw another tangent here. So it's between these two tangents. So it's between that y value and this y value here. All your y values between here. The graph is a secant, 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 until it touches at 1 point and it will become a tangent. So we want to keep it a secant. What do we want to keep it? A secant, not a tangent. So it must be less than 6. We can't say equal to 6. Equal to 6 means it's a tangent. Less than 6 means it's a secant. Right, now find me the other point of contact. Find me the other point of contact. Remember, okay, this is smart. Anyway, I'm going to leave you to think about it. I'll give you 2 to 3 minutes, onliners and on-siters. I want you to think about it. I want you to think about it. I'm just trying to think if nice. Okay. Find me. That means I need this point here. I need that point there. Come, guys. Find me the other point. Find me the other point. You try it on your own. Come, guys. Come, guys. Where is it? So I need to find this other. We know that this is also y equals 3 over 4x. When we calculated that point, or didn't? Right. Wasn't there 2 points? Wasn't it 6 and minus 2? And we only chose the 6 because it was there on the top. Yes or no? Right. Pay attention. Pay attention. Right. We can now use the point. We can now use the point 6 and minus 2. So we got y equals 3 over 4x plus k. We can now use the point 6 on my x minus 2 on my y. Put in this point in here, minus 2 equals 3 over 4 into 6 plus k. Minus 2 equals 18 over 4 plus k. K equals minus 2 minus 18 over 4. K equals, let's go to our calculator, minus 2 minus 18 over 4. Do we get minus 13 over 2? So that's your other point. That's your other k value here, minus 13 over 2, but greater than minus 13 over 2. There we go. Yes? Your other y value, your one y value was 6, your other y value was negative 2. Yes? No. What happened? You just simplified. Okay. The next question now comes where, watch here, another circle. They love this next question. Must I leave it? There we go. There we go. Okay. Another way that you could have found out this x value here is if you equated these two. You could have put 3 over 4x plus 6 for every y in here. You could have done it a different way as well. For every y, you could have put 3 over 4x plus 6. There and there. Would have been a long calculation. You would have ended up with the quadratic equation, and then you choose the positive one plus 6. There we go. When you put it into here, you would have got minus 2. You would have got that coordinate. Now you take that coordinate and put it into y is equal to 3 over 4x plus k, and now you would get y equal 3 over 4x minus 13 over 2. That's another way you could have done it. Right, here comes the last question to wrap this up. The last question to wrap it up. This is question number 7. Another circle. And this is very important. I'm going to write here next to it, important, because there's rules here. Another circle with the equation x plus 3 all squared plus y plus 2 all squared is equal to 36 is drawn. Will circle M, another circle with center M, will it touch or cut or neither touch nor cut? Will it touch or cut or neither touch or cut? Show all calculations. Who knows the rules for this? For 5 marks. Where they give you 2 circles, you don't need to redraw the next circle. Don't do it. You better remember this. Must I give you the rules for this? How many of you don't know the rules for this? Pick up your hands, don't be shy. So you want me, I guess you want me to give you the rules for it. This is very important. So let's put here the rules. We're wrapping up now. Circle, this is the last question. Rules. If the sum of your radii is greater than your distance between your centers, they will have no points of intersection. If the sum of your radii, keyword sum, less than the distance between your centers, then they will have 2 distinct points. They'll cut at 2 points. And if the sum of your radii is equal to the distance between your centers, then they will just touch externally at 1 point, or another word is tangential. The 2 circles will be tangents to one another. They will just touch each other at 1 point. So no points of intersection would look like that, 2 separate circles. 2 distinct points means the 2 circles will cut each other like that. And tangential would mean that they just touch externally at 1 point. Take these rules down and learn them. Going to be asked either in prelims or in finals. Now understand one thing, if the forward is asked in prelims, generally the reverse will be asked in finals. And like I told you guys, this is not the last 2-day program for 2025. We'll be having another 2-day program where we'll be doing the reverse of all of this as it comes towards finals. But it's good to know all these techniques and all these tools. So now calculate the sum of your radius. So your radius of this one is 5. Your radius of that one is 6. 6 plus 5 is 11. So that's your sum of your radii. Now calculate your distance between your centers. Come, work it out. And now tell me what will happen. We're ending now. This is the last question, guys. The last question, and this will give you your 20 something marks, 25 marks for circle analytics. We're then going into tricks. Right, you took all this down. These are just your rules. Right. We don't even need the diagram anymore. That's not important. This is all done by algebra. Let's calculate the sum of our radii.
Can I make an announcement, Mr. Kota?
Give me 1 second. It's 5 plus 6, which is equal to 11. Your distance between your centers. So you got 2 pairs of coordinates. Your first one is 3 and 2. Your other one is -3 and -2. 3 and 2, and you got -3, -2. Now, the distance between your centers is equal to the square root of, let's call that x2, y2. So, x2 minus x1 all squared plus y2 minus y1 all squared. Your distance between your centers is -6 squared is 36 plus -4 squared is 16. Your distance is equal to the square root 40, 52. Your distance between your centers, the square root of 52 is 7,21. So clearly you can see that your sum of your radii is greater than your distance between your centers. Why? Because 11 is greater than 7,21. So according to that set of rules, if your sum of your radii is greater than the distance between the centers, they will have no points of intersection. Please learn. Easy peasy stuff. Full marks. 25 marks here, 20 marks for your normal analytics. Or 15 marks, that gives you your first 40 marks of your paper. Paper 2. 40 marks in the bag. 40 marks in the bag. How's our onliners doing? Talk to us.
They're blazing here.
Are they
Mr.
blazing?
Kota.
Are they on fire?
They on fire, especially Brandon and Jade. They're on fire. They're hungry. Please
I
be
know they're hungry. Let's look at our timing. It's 10 to 12. It's 11:58. Before you know it, today is over. We're going to push until 1 o'clock. We're now entering trigonometry, compound and double angles. He rakidang.
We got a question. You're going to have to come to the front. We can't hear you from here. You can come here
Unless
and we'll
you
entertain
take
your
the mic
question.
to her.
Yeah.
Take the mic.
Okay, no, she'll come here. I'll give it to her. Mr. Ronald has indicated that he needs his attendance register. So kindly do fill out the attendance register.
Yeah,
Here we go.
Hi.
So for the distance, why did we use the bigger R plus the smaller R, or why didn't we use R minus R? Why did you use R plus R?
No, your distance formula is the distance between these two coordinates, your distance between your centers, right? So what's your formula? It's just x2 minus x1. Let me write it out for you, the formula. So if you're calculating the distance between your one coordinates is 3 and 2, your other coordinates is -3 and -2. So the distance between the two is going to equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Agreed? So distance is equal to the square root of, you can call this one x2, y2. So let's go. X2 minus x1 all squared plus y2 minus y1 all squared. So distance equals square root 52, which is equal to 7,21. Your sum of your radii is just 5 plus 6, which was 11. So 11 is greater than 7,21. So therefore, they'll have no points of intersection. Agreed? Thank you. Right, guys, let's go, let's go, let's go. We're going into trigonometry. Let's put down your checklist. Right, checklist for trigs. Number one, you got to know reduction, special angles. Number two, how to complete a diagram, Cartesian plane, and draw your triangle. Number three, identities. Number four, take it down. This is your checklist, guys. Trig substitution. You're going to see it. You're going to get one of each in your paper. Trig substitution, if sine 21 equal P, find blah, blah, blah in terms of P. I'm just giving you an example what it looks like. Number 5, general solution. Number 6, trig graph, 2D trigs, non-90 degree triangles, or 2D or what they call 3D trigs. 3D trigs or 2D trigs. That's your area rule, sine rule, cos rule. 28 and 9, 37 and 13. 50 marks, including your graphs. 50. 50 marks is your trigs. 35 marks would be your analytics. 50 marks will be your Euclidean. 15 marks, stats. And that's broken up into grade 11, and that's grade 12 circle. Trigs is your trigs, your trig graphs, and your 2D trigs. Your normal trigs is 30 marks. Your normal trigs, 30 marks, 10 marks, 10 marks. That will make your 50. Analytics, about 20 and 15. Maybe 15 marks there, 20 marks there. Euclidean, you know. Grade 11, grade 12. And stats, grade 11, grade 12. And grade 12 is only your regression. Now, this is your checklist, guys. This is how you're going to monitor yourself whether you know your work. That's your entire trig component. Now, before we go into this, let's go to our toolbox. We can't build a house without knowing our tools. The reason why most matrics fail or don't do so well, they don't know all the tools. Now, when you don't know the tools, you can't build. So let's do a recap. Come, let's all do a full recap of what we all know from grade 11. Right. So let's put, here's our toolbox. Before we even start with a past paper application. Let's start with the tools. You got to know your tools. Guys, know your tools on your fingertips. Right, so let's open up a toolbox. Let's start with every tool that we know in trigonometry. Right, toolbox. The first thing that we know with your negative angles is that sine of a negative angle is equal to minus sine of that angle. Tan of a negative angle is minus tan of that angle. Cos of a negative angle is positive cos of that angle. That's your first set of tools from grade 11. Agreed? Good. Shh. I'm not teaching you new stuff. This is work you know from grade 11. The next set of tools, the next set is that 90 degrees or 270 degrees, the name changes to the co-function. 180 and 360, the name stays. In terms of reduction. Now pay attention. The next set of tools is what if you have the anti-clockwise angle? Very important. So let's say I told you cos of 270 or x minus 270. What do you do here? Right? Okay, what you can do. You want another shortcut to it? You ready for shortcuts? Right. So here we go. Cos of 270, it's 270. So will the name stay or change? So it will become sin x. Now we need to determine whether it's positive or negative. Yes or no? Right. Here's the shortcut. Watch here. Just draw a rough Cartesian plane. Cos is in your fourth quadrant. We're moving 270 degrees anti-clockwise. So this is cos. So we go from here to here is 90. From there to there is 180. From there to there is 270. Yes or no? What is cos in this quadrant? That's how you change it. Cos 270 changes to sine. Cos lives in your fourth quadrant, ASTC. Cos is in your fourth. We're moving 270 degrees anti-clockwise. What is cos in this quadrant? Negative. The next set of tools that we need to know is the square angle. So if I told you sine squared 270 minus x. Now sine 270 will change to cos squared x. Do I need to check whether it's positive or negative? No. Anything squared is always the next set of rules. There's a whole, I'm just giving you all the tools. One is a spanner, one is a plier, one is a saw, one is a hammer. I'm giving you all the different tools that are required for you to have in your toolkit. Before we even start, because if you don't know your tools, you're going to be spinning. You can work with 100 past papers. You'll fail 100 times. I'm telling you. Many of you come to me and say, yeah, but sir, man, I don't know how I got 30% in a paper. I worked through 20 past papers. Who cares? Did you know the tools? Yes, you worked through it. You looked at the answer. You memorized that. You didn't know how they got to it. So it doesn't make a difference. You can work on 100 past papers. If you don't know the tools, you're going to fail 100 times beautifully. Right, the next tool. An angle greater than 360. What do we do with it? Like cos 540. What must we do? We know a circle only got 360 degrees. So we minus 360 from it. So that will be cos 540 minus 360 is 1. What's 540 minus 360? Oh, we should have made it 420. Make it 420. Make it 420. Make it 420. So we minus 360 from it. 420 minus 360 is how much? 60 degrees. Now cos 60 as a special angle, cos 60 is a half. Hassan, question?
Question, take the
Read.
mic. I'm being ambushed by the comments here.
Okay.
Kouter,
Yeah.
you're not doing your job, eh?
I don't read the
Comments, yeah.
comments. You read the comments.
Yeah, no, definitely, yeah. That's what all politicians say.
Right. So here we go. This was your negative angles. What to do with it? That's what your name. That's what your anti-clockwise angle. That's what an angle greater than 360. And that is what your square angles. So let's write it. What do you do with squares? What do you do with the angle greater than 360? What do you do with the anti-clockwise angle? What do you do when you need to change the name? And this is your negative angles. Right, more coming up. Negative angles. Negative angles. There we go. This is with regard to reduction. What about our identities? What do we know from grade 11? I'm still on grade 11. I haven't even touched grade 12 yet. So learn this. Whatever is on the screen, you got to know. Okay, let's now go into identities. What do we know? What identities do we need to know? We need to know that sine squared theta plus cos squared theta equals 1. Yes or no? Right. So from here we can derive that sine squared theta is 1 minus cos squared theta, or cos squared theta is 1 minus sine squared theta. Guys, if you're going to ask me to teach you this, I ain't doing it now. We are 2 weeks before prelim. You have been at school for 1.5 years. From grade 11. You've been doing this for 18 months at school. Now, this is also a difference of 2 squares. Difference of 2 squares. 1 minus sine, 1 plus sine. Good to know. Good to know. Your other one is that tan theta equals sine theta over cos theta, or tan squared theta equals sine squared theta over cos squared theta. Also good to know that 1 over tan theta is equal to cos theta over sine theta. They like using this one. You know that tan is sine over cos, but 1 over tan is cos over sine. Good to know, you can use it a lot. if it appears. Yeah, my co-pilot. Oh, co-pilot.
Co-pilot putting out fires for you.
Right. Now, let's go into the area rule, sine rule, and cos rule. Quickly, I am just giving you the rules. This was identities. Guys, by now you know area is equal to half of a side times another side. For a non-90-degree triangle, half of a side times sine of the included angle. That's area rule. Sine rule. A side, any side over sine of its opposite angle is equal to any other side over sine of its opposite angle, which we know A over sine A equals B over sine B. Cos rule in any triangle ABC, A squared equals B squared plus C squared minus 2BC cos A. Two sides and the included angle given, we use the cos rule. Area rule, sine rule, cos rule. We're now going into grade 12, double and compound. Know them on your fingertips. I'll show you how to remember it. We'll sing a song in our mind. Okay, we all done with that? Onliners, how are we doing? On-siters, onliners, how are we doing?
Techno Clinic, thank you for the 35 Rand super chat. John Doe says, guys, we got the cash.
Right, you all took this down? Let's go into grade 12. This is work you know. We are just recapping what you already know.
Here's a point. Just clarify for the code in person and online. I've been inundated with requests. Mr. Kota, why are you running so fast? So just clarify that for our in-person code and online.
We have got to finish this. We need to go into application. This is still revision. Even if I speed through the revision, this is work that you know. If we're going to move at a snail's pace, we won't even finish today. We'll cover nothing. We are 2 weeks before prelim. By this time here, you should be fully geared to activate. Right.
Thank you
Let's
for
look at
clarifying
this one.
that point. Thank
Right,
you.
grade 12. Your compound angle. Sine of a compound angle, cos of a compound angle. Double angle. Right, like sine 2A, 2 times an angle, or cos 2A. Right. Sine of a compound angle, how will we remember this in the exam? Sine cos, cos sine, And the sign, S for sign, will help you to remember that the sign stays the same. S for sign, S for stay. So sine of a compound angle, you'll write it out exactly like that. Sine cos, cos sine, the sign stays the same. Sine of a compound angle, sine cos, cos sine, the sign stays the same. Let's all say together, sine of a compound angle, the sign stays. Sine of a compound angle, say it out for me. Last time, sine of a compound angle. Good. Now, cos of a compound angle, be careful. C for cos, C for change. The sign changes. Here you go, cos, cos, sine, sine. And the sign changes. C for cos, C for change. So sine of a compound angle, sine, cos, cos, sine, the sign stays the same. Cos of a compound angle, cos, cos, sine, sine. Sign changes. Sine of a compound angle? Good. And cos of a compound angle? Cos of a compound angle? Sine of a compound angle? Sine of a compound angle? Cos of a compound angle? Yeah, nice, 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 nice. Well done. Now you know it. Now you know it. Now you know it. Don't forget it. Don't forget it. You're going to see how we're going to be applying it now. We're going into the papers now. Watch here. Sine 2a can only be broken up in one way. 2 sine A, cos A. Always. Sine of a double angle can only be broken up in one way. 2 sine of an angle, cos of an angle. Always. But cos of a compound angle can be broken up in how many ways? 3 ways. Cos squared A minus sine squared A. Or 2 cos squared A minus 1. Or 1 minus 2 sine squared A. Depending on what the question requires. If you want it in terms of sine and cos, use the first one. If you want to break up cos 2a only in terms of cos, use the second one. This one is only in terms of cos. This one is only in terms of sine. Get ready. The fun is about to start. We're about to do a 28-mark component on trigs. Let's get full marks here. Using all the rules from the toolbox I just showed you. The only assumption that I have right now is that you are familiar with the tools. Further than that, I assume you know nothing. Let's go through it, item for item, topic for topic, question for question. Which one? Sine 4a. Yeah, sine 2a is only one way. 2 sine A cos A. Yeah, I'll show you that when we get to it. Right, don't even worry about your formula sheets. You got to know your formulas from your head, like how we're learning it now, so that we can apply it. You don't have time in your exam to keep on looking at your formulas. Right, let's go. Let's start. It's the only ones you need to know. Right, let's start. Right, simplify. Simplify tan negative x, negative angle, times sine 90 plus x, plus sine double angle over 2 cos 360 plus x. 6 marks, simplify. That's 1. Let's see another one from another past paper here. Beautiful. You want me to put both down for you? You want to try both? One at a time. Okay. Go for it, guys. Simplify this. Negative angle, name change from our toolbox. Sine double angle, name stay. So we know our tools. We know our tools. Onliners, are we working lekker? Talk to us there, Sanaim. How's our Owens there? How's our Owens?
I think I smell something burning on the stove.
Yeah.
I
They
think-
cooked.
They cooked, yes. Don't
Are
worry,
they
learners.
cooked?
Don't worry. We will be taking that lunch break shortly for a refuel, and we'll also refuel Mr.
Come
Coates'
guys, come guys.
his rocket also. So yeah, that's the status quo there, Mr. Kota.
Come on, this is not difficult. This is easy. This is easy. This is easy. Come. Are they ready already? Must let me know.
We have Awqaf SA CEO, Mitchells Collier, the Prince of Awqaf. Mitchells Collier is in attendance. This is
John
his
Doe, I don't
grandson.
know the answer yet, bruh.
You can give us a
I
round of
don't even
applause
have the
for
memo what
Awqaf
we
SA CEO. He's paying for the meals today. A round
Guys,
of applause for Mitchells Collier. Awqaf in the house. Big ups.
Okay, guys, let's go. I don't know, John Doe. You say the answer is sine X. I don't know. Let's check. Let's check. Give me my board. Right, let's go. Right, tan of a negative angle minus tan X. Did you do that? Sine 90, does the name stay or change? Changes to what? Good. 90 plus is in my second quadrant. Don't look at the changed one. Look at the original. 90 plus is in quadrant 2. Sine is what? Positive. Plus sine 2x is 2 sine x cos x. Can only be broken up in one way. All over 2. Cos 360, the name will stay cos x. 360 plus is in your first quadrant. Cos is positive. Positive times that positive will stay. Minus tan x. What is tan x? Sin x over cos x. So John Doe says the answer is sin x. Let's check. I don't know. We need to get to the answer. Over cos x plus boom, 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 sin x. Now on this side, cos x and cos x cancels out. Minus sin x plus sin x. John Doe, your answer is 0, not sin x. My brother from another mother. Or my sister from another mister. Your answer is 0. John Doe. Online. Talk to me, brah. Yes, your answer is 0. The answer is 0. Well done, well done, well done. Well done, guys, well done. The next one. Throw you into the deep end. This one contains squares in it. Last one on reduction. Last one on reduction. Here we go, guys. Sine squared 180 plus x. Simplify this to a single trig ratio. Times sine of minus x all over minus sine 90 plus x times tan x minus 1 simplified to a single trig ratio. 6 marks. The last one was also 6 marks. Yes, simplify. I'm going to give you guys 3 minutes to do it, onliners and on-siters. Oxygen break. Carbon dioxide break. Carbon monoxide. Yeah. We did a lot of work there. Gang span there. Yeah, you can tell them now they're busy working. Okay. Anything on the side. 3 minutes. 3 minutes, guys. 3 minutes.
So while Mr. Kota is taking that stretch and you are working through that problems, we will be feeding shortly at 12:30. So all the doors will be closed. You'll make your way to the end of the hall and then you'll go out on that side. You're going to have to go outside the wall and make a turn again to come into the wall to come and collect your lunch. That's for lunchtime. So everyone's going to have to leave the wall as I'm pointing it out to you. At the back, you see the security over there. He's pointing his hands over there. He's going to guide you and his team how to get outside out of the wall. All right? Going to have to go outside the wall and just listen to them for your meal. Okay? That will be happening shortly.
What time are we going to go for lunch?
Now 12:30.
12:30.
Yeah.
Okay, then we'll come back and finish
No,
drinks.
but we need to just talk to.
Okay, we are back. We are back. We got 5 minutes to go for break. Your lunch will be ready. Hassanain will take over with the comments, and then we'll come back and complete. We'll do more tricks after break. Yeah, we can break for lunch at 12:30.
Okay, learners. So what we will do now, one row at a time, we'll make our way to the back of the wall. The security will be advising you on the wing. You're gonna have to go out of the wall and come in through the back entrance, and
Let's
that's
do
where
this
you
one
will
first.
receive.
Yeah, I just want to do the memo of this one first. Sir.
Go for it. Take it
Right.
away.
Guys, settle down. Let's do the memo of this one. Then we go for break. We cut for break. What time are we going to go for break? We'll say 12:30 to 1 o'clock because I still got more tricks to do and we got Euclidean to do. Or let's
Okay.
give you till 10 past 1.
No one.
Till 10 past 1. 12:30 to 1:10.
Okay, there we go.
Break.
Learners, please be advised.
Okay, let's go. Right. Sine 180 will remain sine squared x. Do we need to check whether it's positive or negative? Why not? It's squared. Anything squared is always excellent. People are enthusiastic here, bruh. Sine of a negative angle minus sine of the angle. All over. Sine 90 changes to cos x. 90 plus is in your second quadrant. Sine is positive. Times the negative outside will keep it negative. Times, and that's over 1. 10x sine x over. Right. Now we're multiplying and dividing. So negative and negative will cancel out. Cos and cos will cancel out. Sine and sine will cancel out. Your final answer is sine. Oh!
Aibo.
Right. Okay, wait. Now they said they want it to a single trig function. Wait. So this is equal to minus 1 plus sine squared x. Now minus into 1 minus sine squared x. And we know that 1 minus sine squared is what? Your answer, and you will be right, minus cos squared x. Well done. Well,
Question.
how many of you got this one right? Well done.
Question.
Yeah.
Finance. When are we doing finance?
Whoa, if we're cutting it fine. If we've got time, because we lost it 3 hours yesterday, we are in a bit of
Okay,
a
I
jam.
tell you what.
We will try our best.
Okay, thank you.
Okay, guys, we go for break 12:30 to 1:10.
Okay.
You guys got sound? Do you guys have sound? Just go and tell him they got no sound. Okay. Let's go. Sorted. Can you hear us? We are live. Onliners, on-siters, welcome back. It's on now. Let's go, guys. On-siter, onliners, give us a thumbs up if all is good. Right. We are back. Thank you, Raisa. Thank you, Jade. Thank you, Caden. Thank you, Aiden. Here we go. All right, guys, take this one down. Welcome back, grade 12s. Hope you enjoyed your lunch. We're into the last session. We're going to finish up the trigs as much as we can. We'll then take about a 10-minute bathroom break. We'll come back and we'll finish Euclidean till the end. We will be putting up, Asanane, I think we will be putting up the finance and probability on the Awqaf website. I think, Asanane, you can just fill us in as
Okay, so
due to the time that we lost yesterday.
you have put out a request there that you want something on finance. We hear you. So we do have a past workshop that we have conducted on Maths Paper 2, where finance was dealt with.
Paper 1,
Maths Paper 1.
finance and probability.
So we'll post that in the YouTube chat. Okay, thank you.
Okay, guys. I hope you guys all got that. Hi, Jade. Hi, Raymond, Isabel, Zoni, the Black Miner. Welcome. Godwana. Raymond Brown, you good? Let's get started, guys. We are back. Thank you. I like this question. I'm going to use this one as a model and a template. So whenever you see a question like this, you'll be answering it in the style that we are about to answer this. Take this question down. Take this question down. If sine 27 equals P, find the following in terms of P: cos 27, sine squared 63, and cos 13,5. Mark allocation 224. 224. Total marks 8. Guys, I beg you, learn this. You're always going to see something like this in prelims and in finals. Right, again, there's a certain procedure that we need to do. There's a certain process that we follow. The first thing that we do is we draw a Cartesian plane. Follow. Sine is opposite over hypotenuse. And if no restriction is given, we draw it in our first quadrant. So sine 27, that's 27, is P over 1. P over 1. Opposite over hypotenuse. Remember, for a 90-degree triangle, we use SOHCAHTOA. Right? Remember, for a 90-degree triangle, we use, oh hell, another hour of algebra. Sine, cos, and tan. SOHCAHTOA. Okay, now pay attention. The last side, x, we always use before we even start with this. So step number 1, Cartesian plane. Step number 2, SOHCAHTOA, to draw our triangle. Check if there's a restriction or not. No restriction, we draw it in the first quadrant. If a restriction is given, we'll have to check in which quadrant it falls. And number 3, we use Pythagoras to get x. So let's use Pythag, guys. 1 squared is equal to x squared plus p squared. Pythag. 1 minus p squared equals x squared. X is equal to plus or minus the square root of 1 minus p squared. It's to the right of 0, so it must be positive, the square root of 1 minus p squared. We can't say negative. Negative would be here. But we want the positive. Okay. Now we answer the questions. Using SOHCAHTOA, using your rules of reduction, using your rules of compound or double angles. And the last one is the kicker. Half an angle. So somebody asked me earlier on, sir, what happens to half an angle? Remember you asked me earlier the formula for half an angle? That last one, cos 13,5. I'm going to show you what to do when you have half an angle. Okay. Onliners, how are we doing, guys? Light work, easy stuff. Kennedy is on fire here. Let's check. The last one's the killer. The last one's the kicker. The first one is very easy. Let's all do the first one together. Cos 27. Adjacent over hypotenuse. In terms of P, adjacent over hypotenuse square root 1 minus p squared over 1, which is the square root of 1 minus p squared. Yes or no? Easy stuff. Baby work, light work. Now comes the 63 degrees. What is the relationship between 63 degrees and the reference angle, or 63 degrees and a quadrant, or 63 degrees and a compound angle, or 63 degrees and a double angle? Relationship. So obviously there's a direct relationship. 90 minus 27 is 63. So let's answer question number 2. That's easy. The first one's easy. Can I erase? Anybody still taking down question number 1? No? Good. Who's writing the first one still down? Right. Easy stuff. Shh. Question number 2. Sine squared 63 is equal to sine squared. Relationship between 63 and 27 is 90 minus 27. Agreed? Now your law of reduction. Sine 27 will become cos squared 27. Cos 27 was the square root. Cos 27 was square root of 1 minus p squared. Don't forget that squared. That and that goes out. Put the square outside. That and that will cancel out. Your final answer is 1 minus p squared. So you got 2 marks there, you got 2 marks there. Now the thing with this one is, because it's 8 marks, the last one's 4, which is 50% of the question. So you can get the first 2 right. The last one, if you got wrong, you'll lose 50% of the question. The last one's 4 marks. 4 out of 8. If you get the last one wrong, you've lost 50% of this question. Huh? Yeah, but you're only going to get 4. If you get the last one completely wrong, there's no CA. You only got 4 out of 8. Come. Now, there's an art of doing the last one. Now, if you listen to me and take the next rule down, I promise you, you will always get this one right in your exam. Now, you know that 13,5 is half of 27. But pay attention. Whether they tell you cos 13,5 or sine 13,5, they can ask you either that one or this one. You always use the next strategy. You ... use ... Right, now we start. Quiet, quiet, quiet. You guys need to pay attention to this last one. Again, I'm going to repeat what I said. Whether they tell you cos of half an angle or they tell you sine of half an angle, you always start with cos of the double angle. Cos 27 is equal to, in this case, square root 1 minus p squared over 1. You always start with cos. You don't start, even if they ask you for sine 13,5, don't start with sine 27. You will always start with cos 27. I'll show you why now. I'm about to show you why. So put down your pens. After you've taken this, put down your pens. Cos 27, we need to convert to a double angle. Pay attention. Grade 12s, pay attention. Cos 27 will be converted to cos of a double angle is 2 times 13,5. You don't use half. Although this is half of 27, you don't have a formula for half. You start off with cos of the double angle. I'll show you what's going to happen now. Pay attention. Is equal to the square root of 1 minus p squared. Right, so here's cos of your double angle. Now, cos of your double angle has got 3 ways to break it up. Are you listening to me? Cos double has got how many ways? But we need it in terms of cos. Or you can even break it up in terms of, it's up to you. It's up to what the question requires. So cos of a double angle is 2 cos squared 13,5 minus 1. That's your cos double angle. That's your cos. So it's 2 cos squared 13,5 minus 1 is equal to the square root of 1 minus p squared. Now all we do is we make cos 13,5 the subject of the formula. If they asked you for sine 13,5, you would have broke it up at that point into 1 minus 2 sine squared 13,5 and then made sine 13,5 the subject of the formula. Now all we have to do now, algebra. Let's make cos 13,5 the subject of the formula. So take this 1 over onto the other side. So 2 cos squared 13,5 is equal to root 1 minus p squared. Minus 1 will come on the side as plus 1. Right, quiet. Right. Divide by 2, divide by 2. So you're going to have cos squared 13, comma 5 is equal to the square root of 1 minus p squared plus 1 divided by 2 all over 2. Here comes your final answer. They want only cos 13, comma 5. So find the square root, find the square root. Here's your final answer. Cos 13, comma 5 is equal to the square root of 1 minus p squared over 2 plus 1. And there we go. That's your final answer. You start off with cos of the double angle. That's your cos double angle. All this that I'm highlighting is cos of your double angle. A very similar question to this. I'm going to give you now, immediately after this. A very similar question to this, where you're having half an angle in. Take this one down. What happened to my calculator? Somebody knocked it during break. Okay. Somebody knocked. Okay. You've taken this one down. Let me give you another similar one to this. Watch this. Find sine 22,5 degrees. No calculator. For 6 marks. Find the value of sine 22,5 without the use of a calculator. We're going to use the same concept. The very, very same concept. Now we know 22.5 is half of 45, yes or no? But we're not going to start off with sine 45. What are we going to start off with? Cos 45. Like whenever you have half an angle, you always start off with cos. Let's do it together. Now guys, if you're not going to pay attention, you're going to be lost. You need to follow. So let's go. Cos 45. We know cos 45 is root 2 over 2. It's your special angle. Yes or no? Okay. One over square root 2 or root 2 over 2 is the same thing. No. It's fine. No. Root 2 over 2, you can memorize root 2 over 2 or you can put it as 1 over root 2. If you wanted to put it as 1 over root 2, no problem. If you feel like you want to use 1 over root 2, use 1 over root 2. The one is just with the irrational denominator and the one is with the rational denominator. Yeah? Right. Now, cos 45 is cos, I said double angle, 2 times 22,5. Double angle, cos double angle. is equal to 1 over root 2. Now, cos of 2 times an angle in terms of sine. In this case, we only want it in terms of sine. Your cos double angle in terms of sine is what? 1 minus 2 sine squared of your angle, 22,5, is equal to 1 over root 2. This is your cos double angle, and you're breaking the cos double angle up into sine. So you're getting your sine from your cos. Now all we do is we make sine 22,5 the subject of the formula using algebra. So take the plus 1 over on the other side. So we got minus 2 sine squared 22,5 is equal to 1 over root 2. Plus 1 will come on the other side as minus 1. So minus 2 sine squared 22,5 is equal to, go to your calculator. Although they say without the use of a calculator, as long as you don't use decimals, you're fine. You'll get the marks. So go to your fraction, say 1 over root 2 minus 1. So you get minus 2 plus root 2 all over 2. Now we want to get to sine 22,5. So what must I get rid of? The minus 2. So sine squared 22,5 is equal to this divided by negative 2. So that and that is gone. Divided by minus 2. You get 2 minus root 2 over 4. You can check it on your calculator. And we only want sine 22,5. Here's your final answer coming up. Therefore, sine 22,5 is equal to the square root of this whole thing. So it's the square root of 2 minus, sorry, not root 4, it's root 2. That was root 2, sorry. 2 minus root 2 over, we're finding the square root of this whole side. So what's the square root of 4? 2. That's your final answer. That's sine 22,5. Okay. So this was to do with half an angle. So just to recap, whenever they give you half an angle, you start off with cos of the double angle, and then you break that up into cos or sine, whatever they're asking you to find. Okay? The most crucial part of this problem is this, cos 45. You're starting off with cos of the double angle, of 2 times the angle. Whenever you see half an angle, half of a special angle or half of any other angle, we start off with cos of double the angle. They love this. Always asked in almost every paper. Right. What's also important is 3 times an angle. Right. So let's all do it together. I'm going to give you one with 3 times an angle. Then we're going to go into the next questions here from your prelim paper. Okay. So now they ask you to prove. Take the next one down. To prove that sine 3x is equal to 3 sine x minus 4 sine cubed x for 6 marks. Okay. Now you're going to have to put your pens down. We're going to all go through this together. I'm going to write the entire screen full, so you need to focus at every point of this problem. After every step, I'll put a tick. We'll take 3 seconds for you to process. Then you tell me, right, we good to go. Step by step. Okay. So we start on the left-hand side. Sine 3x. Whenever you see 3 times an angle, you break it up into compound. So this is equal to sine compound angle 1x plus 2x. Yes or no? Shh. Guys, the back, you need to follow. Very important question. Very important question. Right. So 3x, x plus 2x. Even if it was cos 3x, cos x plus 2x. Now pay attention. There's nothing you can do with the right-hand side. Sin x and sin cubed x, there's absolutely nothing you can do with the right-hand side. It's our left-hand side that needs to be expanded to look like the right-hand side. Okay, now our compound angle for sine. So I'm going to put a tick here. You all understood that. Right, now pay attention. Sine x plus 2x. That's going to be what? Sine cos sine x 2x x 2x. For sine, the sign stays the same. Boom. All agreed? Right. Now my right-hand side is only in terms of sine. My right-hand side is only in terms of sine. That means I need to get rid of that, I need to get rid of that, and I need to break that up. That sine, I'll leave. So convert everything to sine. Convert alles to sine. Right. Let's convert alles to sine. Everything. So now let's go. Right, work with me here. The next few steps are absolutely critical. Right, sin x. Cos 2x, double angle in terms of sine, is 1 minus 2 sine squared x. Yes or no? Plus cos x, there's nothing we can do, times sine 2x is 2 sine x cos x. You all agree? We broke up the sine double angle and we broke up the cos double angle. Now let's remove the brackets and collect like terms. Sine times 1 is sine x. Positive times negative is negative. 1 times 2 is 2. Sine times sine squared is sine cubed x. Plus, this is all one term, 2 sine x. Cos times cos is what? Cos squared x. Ha! I got sine, sine, sine. Where's my only problem? Cos squared. According to grade 11, cos squared is what in terms of sine? 1 minus, right. So we're going to do again. The problem's going to start working itself out. Watch. Let's all do it together. Sine x minus 2 sine cubed x plus 2 sine x. Cos squared is 1 minus sine squared. Let's remove the brackets. Sine x minus 2 sine cubed x plus 2 sine x times 1, 2 sine x. Positive times negative is negative. 2 times 1 is 2. Sine times sine squared is what? Sine cubed. Let's collect our like terms. Guess what? Here's our final answer coming up. Sine x plus 2 sine x is what? Check my right-hand side. 3 sine x minus 2 sine cubed x minus another 2 sine cubed x is what? My right-hand side, minus 4 sine cubed x, which is equal to your right-hand side. There we go. You'll get 6 marks for that. Danko. Take it down and learn. Take it down and learn. Take it down and learn. Right. Let's go, let's go, let's go. I hope you took this one down. Right. I'll wait for you. I'll wait for you. I'll give you a couple of seconds. For those of you who have taken this one down already, you can start on the next one. For those of you who have started on this one, you can start. This one's from a past paper. If cos x plus sin x equal k, find the following in terms of k. Cos x minus 45. It's easy. They give you 4 marks for that. They give you 4 marks for that. After this, we're going into general solution. Okay. How's our onliners doing there, guys? Thank you, Katie.
Katie says, Kota, you are the GOAT.
Portland in the house. Oh,
John
John Doe.
Doe.
John Doe. Our man John Doe says easy stuff.
Let's do harder
Easy
questions.
stuff. Okay. All right. We're getting to general solution after this. This was the easy one. He says, let's do harder stuff. Can I erase the previous one?
Mr. Kota, I have to admit it, I had fun today.
Yeah.
We're able to keep the whiteboard up.
I'm telling you. Kudos to you. Brownie points to you, bruh.
No, it's all about Samit, eh?
Yeah.
Samit and Adam and the rest of them. We even got some fan mail from Joy Nelson from Spine Road.
Yeah,
eh?
yeah, yeah. People are even drawing me here, bruh.
Yeah, you're a legend. We'll erect a...
People are artists here. Some people are not doing maths. They're drawing caricatures of me. Hasanain, where's my whiteboard?
Yeah, it's all about the whiteboard, eh? I think we should put up a statue
yeah, you guys
outside
are funny.
Spine Road.
All right, here goes. Let's go. If cos x, so they want you to find the following in terms of k. So let's start with that. So this is your compound angle, cos, sin, x 45 plus x 45. Right, cos 45 is square root 2 over 2 or 1 over root 2, if you say so, times cos x, plus sine 45 is 1 over root 2 times sine x. Let's take out, we want cos x plus sine x. So let's take out 1 over root 2 as our highest common factor. We left with cos x plus sine x. And we know cos x plus sine x is equal to k. Your answer is 1 over root 2 times k over 1. Your answer is k over root 2. Agreed? Good. Before we do that one, let's give you a bit of a killer one. So the next one goes out to John Doe. John Doe. Right. If sine 36 cos 12 equals P and cos 36 sine 12 equals Q, find question number 1, sine 48, sine 24, and cos 24 in terms of P and Q. Right, the first one is 2 marks, 2 marks, 4 marks. 8 marks again. How many of you have seen this question before? 1, 2, 2, 3. They're lying. Where you saw it? If sine 36 cos 12 equal P and cos 36 sine 12 equals Q, find this in terms of P and Q. Shh. Quiet. This is important. Let me help you with the first one. John Doe, how are we doing? Where's my brother John Doe? John Snow. Yo, we got John Doe, John Snow. Brah, we've got, mashallah, my head is shiny. As long as they're looking at my head, no problem. Don't worry. The shiny head will be smiling when you're writing prelims and finals. Right, let's go. Sine 48. Let's answer the first question, sine 48. What is the relationship between 48 and 36 and 12? Is equal to sine 36 plus 12. So that's compound angle, sine cos, cos sine, 36 12, 36 12 plus. Now we know sine 36 cos 12 is P plus cos 36 sine 12 is Q. Your answer for the first one is P plus Q. Shh. What do you think the answer to your second one is going to be? 24. What's the relationship between 24 and 36 and 12? 36 minus 12, am I right? 36 minus 12 is how much? 24. Guys, whoever is whistling there at the back, please stop. No, never.
It's a bird.
It's a freaking bird.
No more Red Bulls for you.
I'm flying. I'm high on math.
Mr. Kouter, please lay off the Red Bulls, please. Clearly.
I'm flying. 36 minus 12 is sine 24. I'm answering question number 2. Sine cos sine 36 12 minus. So your answer is P minus Q. I'm sure you all got the first 2 right. It's the last one that's going to wreck your brain. What? Yeah. The next one is torture. It's abuse.
So what emoji?
Now you can't use cos, you can't say cos 36 minus 12 because then you're going to get cos sine. And you don't have cos sine in terms of P and Q. You can't say 2 times 12. There's no 12 degrees only. So you can't convert it to a compound and you can't convert it to a double. What are you going to do with it? So I'm just putting our answers here. Sine 48 was P plus Q. Sine 24 was P minus Q. So 2 marks there, 2 marks there. Now the last one, cos 24. Who's sharp? Let's see. 700 of you sitting here in front of us and a couple of thousand there online. John Doe, talk to me. What's your answer? John Doe is buffering.
Maybe his whiteboard is not up.
Close the question. The black minus says he finds it fascinating. Like how are they going to find some of your marks fascinating too? KD Christian says, I'll be joining all the lessons to come. Lovely. Let's go. You want me to take you out of your misery? No, you are trying. Can I show you a trick? Can I show you a trick? Don't you know from grade 11, check this one out. Don't you know from grade 11 that cos squared 24 is 1 minus sine squared 24? Isn't that an identity from last year, grade 11? Now check here. Check here. So we square both sides. If we square this, we got to, so watch. Cos squared, this is your identity, grade 11. So cos squared 24 is equal to 1 minus, let's go back here, 1 minus, we got sine 24 in the previous one, P minus Q. Sine 24 from question number 2 is P minus Q squared. And now you want your final answer. Therefore, cos 24 on its own What's the opposite of square? Square root. And here's your final answer coming up. Done. 4 marks. But at least you know now how it's done. So if you get confused in the exam, think square identity. That's what I'm here to do. Show you how to think, what to think about in the exam. Onliners, showing you flames today. Kennedy's with us, brah. Yeah, ne? I mean, let's go. General solution. Your brain, your brain. Right. Thank you. Take this one down. This was from a prelim paper. Answer. I'll give you guys 2 minutes. All right, I'll give you 3 minutes. Huh? No. 3 minutes, guys. 3 minutes for you to do this general solution. Yeah. Oxygen break. For me.
So Mr. Kota is just going to go stretch his legs and get some fresh air so he can power up and complete the session. So that's 2 minutes for Mr. Kota. We got Mr. Phillies from Portland High School, the legend himself. This is one of Mr. Kota's learners. This maths teacher from Portland High School was part
Guys,
of Mr.
I think you
Kota's
need to
class.
give Mr. Levert a nice round of applause.
Woo! Yeah! In the house.
Just to tell you, many years ago, when Mr. Levert is now a maths teacher, he was also part of the program. He was also sitting just like you guys in Mondale, am I right?
Yes, at Mondale High School back in 2011. 14 years ago.
14 years ago, Mr. Levert was also a product of the K-Way Awqaf program. Today, Mr. Levert is a maths teacher here at Spine Road High,
Portland High School.
Portland High School. So big shout out to Mr. Levert from Portland High School, who's been a product of this program. Today, he's a maths teacher. Thank you so much, sir. Amazing.
Okay, you're still doing the counting paper.
Yeah, I'm finishing it, yeah.
What you see on screen is the cohort of learners from Lushlaza High School. It is happening at Lushlaza High School, the Awqaf SA Grade 12 Maths Workshop. You are live on the screen, Lushlaza High School. You can wave to the screen. Thank you.
We are back. Right, that was Mr. Levert from Portland's, also a product of the intervention in 2011. He was a matriculant. He was battling in math, and today he's a maths teacher. So yes, kudos to you, Mr. Levert. Let's go. 4 sine squared theta Cos 90 will change to sine 2 theta. 4 sine squared theta is equal to 2 sine theta cos theta. Now please guys, do not ever divide by sine theta. Don't ever get rid of a value. I know some of you did it. Who did it? Don't. Because then you're going to lose out on one general solution. You've got to factorize. So let me show you what we do. You take this on the other side. Do not divide both sides by sine theta. So 4 sine squared theta minus 2 sine theta cos theta equals 0. Now watch here. This explains to you why. Now we take out sine, we can take out 2 sine theta. We're left with 2 sine theta minus cos theta equals 0. Now if you divided by sine theta, you would have lost this general solution. And that's why a lot of you lose marks in the exam. You see, you never ever in general solution get rid of any trig function. You don't. You can convert sine to cos, sine over cos to tan, but you can't get rid of a trig function. So now 2 sine theta equals 0, or 2 sine theta minus cos theta equals 0. So sine theta equals 0 over 2 is 0. So theta is equal to shift sine 0 is 0 degrees plus k times 360 for sine. Or theta is also equal, you would have lost both these, 180 plus k times 360. Yeah, then you will only get this one on that side. You would have lost marks here on the left. Now on this side, 2 sine theta is equal to cos theta. Divide by cos, divide by cos. You're going to get 2 sine theta over cos theta equals 1. If I divided both sides by cos theta. Divide by 2, divide by 2. You're now going to get sine theta over cos theta equals 1 over 2. Sine over cos is tan theta is equal to a half. I'm just going to put the solution up here. Theta is equal to shift tan a half, 26,56, 26,6 plus k times 180 for tan, where k is an element of integers. Okay? I'm going to do one more very popular one, general solution. One more very popular one. Our onliners, did we get that one right? Onliners, did you get that one right? I hope you did. Give the general solution. for 6 marks. Let's see who's the boss. You get this one right. This is a higher order question. And I've seen it in 3 past papers. Guys, not only can they ask you, they can say this is f of x and g of x. And they can say, where is f of x minus g of x equal to 1? Show all calculations. Or find the points of intersection. Higher order. I'm trying, guys. The reason why I'm choosing these questions is because I want to expose you to the different style of questions. If I'm going to be doing the same questions as you're seeing in school, then you have just wasted your time this weekend. So I want to expose you to certain of the questions that possibly, I'm assuming that many of you haven't seen. But you have the ability to do it if you know what to do. And it's all part of your syllabus. This is all part. I'm not taking out from anywhere else. This is all part of what is required for you to know. Come, guys. Come, guys. After this, we're going to give you a 10-minute bathroom break. Now I get a round of applause. Only 10. What's the time? Woo, then we come back and we do Euclidean. Right. Let me show you some magic. You want to see some mathematics? Right. Let's lift the sleeve. Let's go. Watch. Guys, follow. It's an equation. What I do on the left, I have to do to what I do to one term, I can do to any term. Am I right? So check this out. Guys, grade 12s, check this out. I'm dividing everything by 2. Check here. Wait, I'm showing you something quiet. I divide that by 2. I divide that by 2. I divide that by 2. Now wait. Talk to me. Get my board up. Whiteboard. Lost connection. Reconnecting. Right, we got a bit of a lag here. Let's see what's going on here. Let's see if it's coming up. Hassanain! Where's my bra? Where's my bra? how, okay, let me go there. Let's say go there, window there, there. Let's see. No, but wait. Hasanain, it's now showing on his side. Mustn't he upload me? Look here. There we go. I think I'm on there. Where is he? Get me live. Get me live. There we go. Something's happening. Yeah, there we go. There we go. I think so. Yeah, just expand me there. There we go. There we go. Here we go. Sorry about that, guys. Thank you. It drop out. Kick out. Okay, here goes. Shh. We divide everything by 2. Now I know you're going to ask why. Obviously, I'm going to give you the answer. Shh. Put your pens down. Put your pens down. Watch why I divided by 2. Watch. Check this out. Now you're going to look at it and you're going to say, wow. Watch. What is root 3 over 2? Special angle. Sine 60. Sine theta minus half cos 60 cos theta equals a half. Sine cos. Flip this over, will be minus cos 60 cos theta plus sine 60 sine theta. Watch. Is equal to a half. Divide by negative, or take out the negative. We're going to have cos 60 cos theta plus, minus sine 60 sine theta is equal to a half. Divide by negative. Cos sine is your cos compound angle. 60 plus theta is equal to a half. Shift cos half. Shift cos half. No. Shift cos minus a half is 120 degrees. So watch here. 60 degrees plus theta is equal to plus minus 120 plus k times 360, where k is an element of integers. Right? Now, you break it up. 60 plus theta will equal to 120 plus k times 360, where k is an element of integers, or 60 plus theta will equal to minus 120 plus k times 360, where k is an element of integers. Remember, for cos, we always put plus minus in front of the angle. So theta is equal to 120 minus 60, 60 degrees plus k times 360, or theta will equal to minus 120 minus 60, minus 180. This was the trick, to divide everything by 2. So you can get special angles involved. Otherwise, there was no other way that you were going to be able to do it. I'm just doing that. Take this one down. Go home. Practice on these ones that we've done so that you are familiar with them. Let's look at our timing. It's 20 past 2. We only got 40 minutes left. 10-minute bathroom break. I'll see, then we will do Euclidean as soon as you get back. So, guys, enjoy your 10 minutes. Enjoy. Leave this one on. Leave this one on. Go for break. Take your 10 minutes bathroom break. Come back. I'll leave it here. Enjoy your break, guys. 10-minute bathroom break. Three on the dot. No, I'm sending them out now for 10 minutes. I've sent them out. Yeah, we're going to hit the last session hard till 3 o'clock. Okay, guys, 2 more minutes, and we get started. tan chord theorem, exterior angle at center equal 2 times angle at circumference. Proportionality, you need to learn the proof. Then you're going to get easy, and you're going to get a rider. Similarity, you're going to get easy, and you're going to get a rider. Guys, and you might even get one question on Pythagoras in a circle. Thank you. Thank you. Guys, it's our last 30 minutes. Let's push as much as we can. Last 30 minutes, we're going to finish at 3 p.m. on the dot. Been a rough 2 days. We've covered a lot of work in 2 days. The whole of algebra, the whole of calculus, the whole of functions, analytics, circle analytics, the whole of trigs, and now Euclidean. Guys, I know because of yesterday's 2-hour delay, so we're short on finance and probability, but what Hasanain is going to do is put up the link from our previous workshop on probability and finance, send it through, it's the same content. Hasanain will share that link for you guys. It was only due to that's how I lost 2 hours. But otherwise, that would have been completely done. Okay. Certain things are beyond our control. Right, guys, let's start. Now that you've got this mind map. So if it's out of 50 marks, this part here is only 10 marks. That means you can score full marks there. Full marks here, full marks there, and full marks there. You can get a minimum of 40 out of 50. You can get a minimum of 80% for Euclidean. Even if that last one you didn't get right. So don't panic. They allow you opportunities to get 80, 85, 90% for Euclidean, even without that last heavy rider. So don't let that one question right at the end break your spirit for the rest of the paper. Get everything right. Regression is easy. Stats is easy. It's last year's stats. Mean, median, mode, standard deviation, variance, modal class, box and whisker diagram, one standard deviation away from the mean. Your least squares regression line, your line of best fit. That's it. Shh. Analytics, 20 marks, grade 11. Circle analytics, I showed you how to do it. The whole of trigs, apply yourselves. Trig graphs is last year's trigs, nothing new for grade 12. This, 90%. There's no way you cannot get 90% for this paper. But you have to work. Right, let's go. You've taken all this down. It's just a mind map. Let's start with the riders, guys. Let's start off where you can score. Right, so let's put a circle in. Right, take this one down with me. O is the center of the circle. Let's get our lines in. So we got a line coming this way. We got a line going that way. A line coming across. We got a tangent going here. We got a line going from here straight across. And we've got a line joining these two dots. There we go. That's your diagram. This is point C, that's point D. That side, this is B, this is 22,5. That's an isosceles triangle. Guys, we'll always be using isosceles triangles. Because the minute you have a circle, you have radii, and radii create isosceles triangles. This angle here is 22,5, 22,5, that's that angle. This is D1, that's D2, that's O1. This is B, B1, B2, that's 22. This is angle A1, A2. Okay. In the diagram below, O is the center of the circle. The minute they tell you O is the center of the circle, look for your radii. So you know that that side is equal to that side. You already know you got an isosceles triangle, triangle OAB. BC is a tangent to the circle. So they're already telling you, you'll have to use tan chord theorem in your answers. They tell you BC is a tangent. So that is an instruction that all your theorems with regard to tangents will be used. DBC is 22,5. CD equals BD. Right. Now, here we go. Questions here for your first, from the prelim paper, 14 marks, but broken up. Question number 1, find the size, let's all do it together. It's not difficult. A1, D1, B2, O1. 2 marks each. So it's only answer, reason, answer, reason. Then, the next question, prove that OA is parallel to CB. Prove that OA is parallel to CB. If it is further given that the radius is 12, calculate the length of BC. Question number 6, if it is further given that the radius is equal to 12, calculate the length of BC. Find the length of BC. This one is 2 marks. That one's 4 marks. Total marks 14. 6, 8, 10, 12, 14. There we go. Right. The first thing we identify is we got, that's 22,5. That must be 22,5. Isosceles triangle. We also know that we got a bow tie in the middle of a triangle, so in the middle of a circle. So you know, if you got something that looks like that, which theorem applies? Angle at center is 2 times angle at? Good. So you must be able to picture the theorem within the question. Let's find angle A1. Angle A1. Right, so we want this angle here. Okay. Now angle A, it's only a 2 mark question. So again, it's going to indicate the level of difficulty. They told you this is a tangent. So let's look at tan chord. Can we use tan chord? A1 forms part of this triangle here. That triangle from there, there to there, there to here. Does it touch the tangent anyway? Yes, it does. There. So immediately we know this angle here is equal to that angle there. A1 is equal to angle B, which is equal to 22,5 tan chord. So immediately go back to A1 and put 22,5. There we go. We're done with question number 1. Question number 2, D1. Now let's look at, come on, sum of angles of a triangle. But you have to first prove that this is isosceles. So you're going to say BD is equal to CD given. Therefore, triangle BCD is isosceles. Therefore, angle C is equal to 22,5. Angles opposite the equal sides. Now, therefore, D1, sum of angles of a triangle, therefore, angle D1 is equal to, in fact, you don't need to show all the, immediately you can say 180 minus 45, which is 135 degrees. And now you can say, why is it so? Sum of angles of a triangle. There we go. D1 is at 135. So we know angle D1 is 135. 135. That's angle D1. Angle B2. B2 is here. Ah, nice. Okay. What is the relationship between B2 and anything? There's no direct relationship. The only thing now that you can see is that a radius is 90 degrees to a tangent. A radius is 90 degrees to a tangent. So obviously B2 will be 90 minus 22,5. Angle B2. Let's go. Let's do angle B2 together. We're doing question number 3. Angle B2. So in fact, you're going to say OB is perpendicular. OB is perpendicular to BC because your radius is 90 degrees to a tangent. Therefore, angle B2 is equal to 90 minus 22,5, which is equal to 67,5. So there we go, 67,5. You got 6 marks already. Angle O1. Now we need angle O1. Let's see what's happening here. Angle O1 is 2 times, angle O1 is directly, angle at center is 2 times angle at circumference. All right, so I know what we're going to do with angle O1. Angle O1, so we're done with all of that. Number 4. O1 is equal to 2 times angle D2. Angle at center equals 2 times angle at circumference. D2 is 45. D2 equals 45. Adjacent supplementary. Angles on a straight line. Therefore, angle O1 equals 2 times 45. O1 is equal to 90 degrees. Now, if O1, I'm just showing you, if O1 is 90, that means that plus this whole angle is 90. So we divide it by 2, so that must be 45. A2 is also 22,5 because 22,5 plus 22,5 will give me 45. That's also an isosceles triangle. Next question. Prove that OA is parallel. So let's look for alternate angles or corresponding angles. Done. It's done already for us. O1 is 90. OBC is 90. Alternate angles are equal, therefore the two lines are parallel. Finish. So let me write it for you. I'm doing question number 5. O1 equals 90. Asanine, whiteboard. No. Check. Are we back up? Till 5 o'clock. They want to move till 5. Come, Asanine. Get me up. That's what I did. Wait. Let's see. Are we live? Get me a screen here, brah. Just connecting. I've been kicked off the...
Samit, over here, Samit, we need your assistance for the whiteboard.
I'm off from the... It says connecting. Huh? Yo, I don't know what's cutting here.
Is this the school's internet? Yeah, I'll pull it out. Okay. All right. Give it a second here.
Look here.
What's it? I put the cable out and I put it
Yeah,
back in.
yeah. So he's using from him and his data ran out.
Let me just see if you can make it.
It's connected there.
Are you connected?
No, wait, let me see.
No, it's just connected on the internet.
Yeah, I'm connected. Are you connected via your phone? So how are you gonna? Fail to connect to server. Yeah, there's it. I'm connected. There's it. I'm connected. Okay. Just give us a minute or two. All right, time is up. Okay, guys, that brings us to the end of today. Sorry about that. Guys, it's been an amazing 2 days. I just want to say thank you all. You guys are absolutely amazing. Calculator, thank you so much.
Okay, thank you, learners. We'll see you again in October.
We'll see you again.
Thank you so much. Thank you.
See you guys.